Hello. Yes, I can use this also. Cool. Hello, everyone. Welcome to the Open Data Devroom at IndiaFOSS 2025. Uh, I don't think I have anything to say in logistics. If you're watching from the live stream, welcome. Hello. Uh, and we're going to start with our first talk. Uh, this is a Devroom that has been curated around open data. We wanted a bunch of talks around not just open data, but the surrounding ecosystems that cover open data. And our first talk is going to be from Raw to Relevant from the Data for India team, Pragnya and Arpit. Please welcome them with a round of applause.
Hello everyone, can you hear me fine? Can you see the screen fine? Awesome. Um, Hello, I am Arpit. I lead the audience in product efforts at Data for India, and with me I have Pragnya. Pragnya is the engineering lead at Data for India. I'm very excited to talk about what we have in store today, but before I do, I just wanted to do a quick question for everyone. I just wanted to know how many of you here have ever worked on making an open data platform in any shape or form? Like, awesome. Now I have a harder question. How do you feel about your audience receiving the data for that platform, that open data platform that you have built? Do you feel it's fulfilling the potential that you had? Do you think it has some way to go, or do you think it is not there yet? It is a long way to go for you. Like, how do you feel about this? Long way to go. So we have one long way to go. Anyone else? Always long way to go. So I'm. Thank you for validating my feelings. I have always felt that. I've always felt there's a long way to go, and I think Pranya felt that too. And I think both of us in previous lives in previous places worked at making data accessible, making open data platform available, and we are like, oh, now there is so much more data than ever. People will come and use it. But we would not be able to do that. We would not be able to convince people to come and use it. So we were like, because they were like, hey, this is the data also available there. These are just files. These files are available in the source also. I can download from there. So we were like, okay, we'll build tools to make it easier. We will put in charts, tables, views. Like now, everyone says, hey, you can just ask an LLM to analyze the data for you. And we would do these things too, and then the users would still not come. And these were the users who were excited about this work. We talked to them. We thought citizens would really be excited about learning about their local communities. NGOs will be interested, researchers will be interested, and they told us they were interested, but they would not come. And and we would kept asking, like, why is the adoption not here? And the question that I would ask, and many of around you are asking, are we looking at it wrong? Is the real problem data not being available, or is the real problem the data literacy to be able to use that data? And what if we need to start there? What if we need to start with making data literacy happen first before people are able to work with the data and use with that data? Because I was facing the same problem. I was working on publishing things on this platform, but when I had to write about the data on that platform, and I would spend days and days thinking about how to understand a metric, write about it. And I am publishing this, so I should be better at it, but I wasn't. And I think that is a lot of what Data for India tries to solve. Like, and which also is in our mission, Insights, Chart and Data, to create shared knowledge and expand our understanding of India. Because understanding is more important first before you even start working and using open data. Because if you don't understand a metric, are you able to actually work with it? Do you feel confident about it? And we have been trying to do it with a more diverse team than earlier. We have researchers and writers who understand this data more. And to talk about a lot of this work, I want to hand it over to my colleague Pranya. Yeah.
So, like Arpit started, I also want to ask a question before I start. How many of you here have heard of Data for India or engaged with it before? Great. So we are a small team of 9 people who come from various backgrounds. We have engineers, we have researchers, we have journalists. All of us work on Indian data and write about it. And to understand what we actually do, we'll today start with a question and work on finding answer to it like we do at our organization for any story that we write. So how many road accident deaths occur in India every year? The question seems very straightforward, right? And the answer could be, say, maybe 50,000 deaths happen or 100,000 deaths happen. But it's not as straightforward as we think. And to answer this question, we start with looking at multiple data sources, find out where this data actually comes from. And these are all the data sources that we use. Most of them come from Indian government, or they come from agencies like World Bank, WHO, or UN. And we use data from only these sources because they're all methodically rigorous and they're transparent in their methodology. And all of this is also overseen by experts. So we know that the data can be verified. And what it ensures is anything that we publish is also a citable resource. So from all the data sets or sources that we have seen, we figure that there are 3 different sources that produce data on road accidents. Now, the first is SRS, Sample Registration System. It enumerates births and deaths from household interviews or local hospitals and produces data on indicators like birth rate, death rate, and fertility rate or infant mortality rate. And then there is National Crime Records Bureau. This records data on crime, which also again includes road accidents. And then there is MORTH, which collects data on everything related to roads, what's happening on it, which again includes road accidents. Now, what does it take to for us to take this data and then convert it into a story and publish on our platform, right? What happens behind the scenes for us to go from raw data to something, publish something that actually is readable for laypersons and for them to understand it, right? Also, what open source software do we use for us to be able to achieve that? First step is sourcing the data, right? And like we have seen before, there's so many data sources that are available, and every single source produces data in different formats. They could be CSVs, they could be text files, or they could be Stata files. What we have done is built a small utility that takes all these files and then converts them into a Parquet file. So you give it a CSV, it converts into a Parquet file, or you give it a Stata, it converts to a Parquet file, or you give it a fixed width file, it asks for a schema and then converts it into a Parquet file. Right? And we chose Parquet files because it stores data in columnar format, and accessing data becomes really efficient. It also compresses data really well. So we use up lesser space, right? And now, once we have data that's sourced into Parquet files, what do we do next? Because dumping all of these in a single place is only going to make our lives harder going forward. But we need some way to organize all of these files better. So we have come up with a 2-layer storage approach. First is metadata layer, and then the other is the actual Parquet files that we have got from the previous step. Now, both of these structures look similar to what you're seeing here. First is the survey, which could be NFHS or NSS, or could be the source that is producing the data, or like World Bank or so. And then the second layer is the rounds that go into, that were done under that survey. So for NFHS, you have NFHS 5, 4, 3, 2, 1. And under every single round, you have the data as tables that were produced under each round. Now, we chose this structure because this lets us scale it easily. Now, if I want to group a few surveys later on, I can do that easily by adding another layer on top of it. Or if I want to add relations between tables, I also will be able to do it. So this has the potential to turn it into a graph-based structure as well. And I'm telling that this can be done because we have recently done something like that, added a statistics layer to each of these tables that are present here. And every single entity that you see here is basically a node that contains metadata of that node and relationships of that node again. So every single table has columns also under it. Now we have figured out how to organize it, but how do we give all of this data to our team members to work with that data and maybe explore it or find some insight? And to do that, we have built a web app that's currently internal, but it's built using React and Fast API, which basically lets or shows all the metadata in a searchable format and then lets you explore. So if let's say I want to work on electricity, and I know electricity is present in NFHS data, but where else is it present? Or is there any other survey that actually gives out data that helps me find contextualize it, right? The metadata layer that I was talking about before helps a lot here, because there's so many data sets that are available, and I would want our team to be able to work through all of them. And once I've figured out which source has the actual data, we would be able to go to that specific table and query it. And this way, we'll not have to get all the data to work with it first. We know where that specific indicator is. I'll go get that specific table and only then figure out which columns I want and only get those specific columns to be able to explore it or work with it. So after querying, it looks something like what you see here, a small table which has this which has the specific data that you're looking for. Now, even having this data is not enough, right? To scroll through so many records and work out what is happening there is still a tedious task. And for our team to be able to consume that long data and find some insight within that, we've also included a charts library, which is sort of a wrapper around chart.js and eCharts. And we use the same charts library to embed charts on our website as well. And our philosophy for charts is that they should not be complex, because not everybody can read charts as we do, or it's not as easy as we think it is for everybody to understand charts. So any chart that we publish is always minimal. And so initially, when we've set this up, we wanted something that that can be really easy or works with React, because we already have a React ecosystem, and something that renders really fast. And Chart.js was that for us when we started, right? But as our audience grew, we have figured out that Chart.js, because it renders as canvas, it's not accessible to everybody. And we also needed something that works with even larger data sets when we look for building some sort of explorer that we give to more tech-forward audience. So eCharts is helping us solve those problems. And also, if we want to build more types of charts later on, it's going to help us there as well. And having charts is not enough, right? Charts, yes, will give us a number, but how is that number getting there, or what is the context around it? Now, like in this question I was talking about, road accidents, how is the number calculated? What is considered and what is not considered? Are indicators like were they wearing a helmet considered? Or let's say, I'll also give you another example. Now, if I want to look at literacy rate in India, I'll say literacy rate in India is 80%, but we don't actually know what goes into that 80%, right? It could be, it's collected in different ways in different surveys. So some surveys go and ask head of the household, are people in your household literate, or did they go to primary school? But some surveys go a step ahead and actually test people for their literacy or numeracy skills. All of this context is really important to understand the numbers that we're looking at. And to write all that context, we use Ghost Editor. And we've picked Ghost because, again, it's open source, and we can customize themes as much as we want. And the editor interface is also really clean. And it also has subscriptions, analytics, and SEO all out of the box. All we had to do was Ghost install, and we are good to go. And anything that we publish, both content and charts, they are free to download and free to be reused under Creative Commons license. And this is our way of opening up content and giving back to the open data community. And we also have a page using our work on how to use our content, reuse our content, and attribute it to us. So coming back to the question, how many road accident deaths happen in India, right? In the year 2022, there were more than 160,000 deaths that occurred due to road accidents. But this number is coming only from MRTH, which gets its data from FIRs, police records. But which means all these numbers are just the reported ones. But SRS, which does individual household interviews and gets data, it says the number is actually double of what we have seen. So that's what I meant when I said context to these numbers is important. And that is what Data for India is doing, bringing both technology and research together. And we are at the intersection of that.
I think for me it's always fascinating to realize that how, like, I would always look at newspapers or I would look at reports and I would see one number and I would take that number as the truth, that hey, this is what it is. But I think every day Data for India, even when I'm making charts, like the researchers tell me that hey, oh no, when you're looking at this number, every time I ask a question, there's such a long answer on how this number has come across. And I think that is very important. Like the work Pragnya does and a lot of our technology team does is enabling the writers to do everything themselves. They are not dependent on anyone else to analyze the data, make the chart, write the narrative. The stack that they have built helps them do that. So, and I think that is very important. Like, while I feel very proud about all of this, I also want to acknowledge we have not solved the entire problem. Like, I also want to point out that we have just started solving this problem, and we are always learning new things about how users engage with data and what does it even mean to advance understanding, which is more important for us than maybe just hey, providing access to open data. And I want to leave everyone with like 3 thoughts about this, and these 3 questions that we are also trying to solve. First is, how do readers even engage with data informed narratives? And this is a question I hold a lot, because our work is not used just by us, but even other publications like Pulyabazi or newspapers, or even Zeroda, who's like ever present at IndiaFOSS, like they use our work to inform a lot of their readers and customers. And I want to take a specific example of things that we consider as obvious. Sure, these things have been solved for, but they are not. Like, so there is this chart that we have which talks about type of self-employment by gender over time. On the left, you will see female self-employment. On the right, you will see male self-employment. If we focus specifically on the female self-employment number, you will notice the red unpaid helper line going down and the blue own account worker line going up. The colors are a little saturated, so you can't distinctly look them here. But when we put this chart out, one of the readers actually wrote back and asked us, hey, but isn't the own account worker line going down? Because they didn't attach the color to the line. That's something you consider so obvious that, hey, if you are giving something a color, it is, but they took the position as the indicator of what that label is rather than color. And these are the fundamental things that are being questioned when people actually try to understand the data, and they just are not data thrown on them. Like another example which is not here is like no one understands stacked area charts. We like to believe people do, but if we really want to bring people to like information, everyone tells us, hey, but how do I read this chart? Every time we put out a stacked area chart, even within the team we argue, hey, do you really understand this chart? And we consider these things as so fundamental, but they are not. And we have to ask ourselves, what is the right way to inform people through data if we want to? So what we are doing internally is we have created this 10-point matrix for us to ask ourselves that, hey, any new chart type that we are introducing to our audience, is it doing all of these things right? And there's a very long list in each of these 10 points, but we want to show any new chart type that we release makes sure these things are up to the standard that we feel are important to advance our understanding. This not just include things like how the charts you engage with the charts on the platform, but because our work is also accessible for other people, how can they download these charts and still work with it? You can see our charts don't really look great on slides, but they look great on the platform. We are ourselves fixing these problems. The second thing I want to implore is, what does it mean to share information with people? Do you start with curation or do you start with exploration? So right now, on our platform, we have these 6 verticals. If you come to the website, you will see a menu with these 6 verticals: population, health, economy, work, living conditions, and measurement. But do people really understand these terms? Even if people do understand these terms, do they understand the technical terminology under something like work, which is labor force participation, workforce, labor force? Like, we are actively working on building a glossary, so when people are engaging with a narrative, they at the same time learn the meaning of the term before they engage with the data. Again, literacy is more important than them being able to use the open data. Them being able to take the point is more important. The final thing we have been asking ourselves is, what is the right user experience to actually introduce users to data? Like, how do we do that? Like, if fundamental literacy is the challenge, what is the first thing that we want to do? And a lot of time, like we discussed in the beginning, the users who use our work are very highly informed users who have already built a trust with our work, who already know us or who have partnered with us on this work. But the goals we have of taking the open data platforms to everyone, how do we do that? How do we introduce them to this information so they feel comfortable engaging with it, and the usage will follow? We expect usage and then come to this. Yeah. So I want to leave everyone with that question, and yeah, end it here. If I don't know if you have any time for any questions, but thank you. Yeah.
Any questions, anybody? Yes.
Hi. How do you establish lineage that when a researcher is looking at a set of data and you are enabling some provisioning for that data? How do you establish lineage of the data coming from various sources and also lineage while a researcher is looking at that data or when you publish that data to the consumer of that this data source or this intelligence that we provide is coming from such sources, and this is what we did to come to this? How do you do that?
So I think 2-part answer to this question. One is that measurement vertical that we were pointing out to you earlier, one of the verticals. Anything that we publish on our platform, you will often see it complemented with a measurement piece that talks about what we looked at in the data, what we understood, what are the definitions, and how do we use it. That is on understanding the data. Specifically then using the data, so we have very stringent guidelines that we don't make any changes to the original data. Beyond aggregations and cleaning it up, like removing NA values, etc. Maybe Pranay can talk about the process a little bit more. That we don't want the interpretation of the data to be our models or aggregations that are beyond the basically accepted statistical standards. We also take care of that. Yeah. You want to talk about more of the process? Yeah.
But when you start to establish correlations between two data points, but when you start establishing correlations between two data points, and if you want to make it a causation, for example, how do you end up doing that? Or do you not do that at all? Because one of the things about intelligence is how do you connect two dots that are disparate?
I think causation is I think you are talking about something that is very hard. These subjects and verticals that you're talking about, we look at it from a very singular lens. A lot of the things that happen in society, like metrics across these verticals might impact it. So to even worry about something like causation is, like, I would say, still very, very far down the line, even for like researchers who are in this field for a very, very long time. Yeah.
On that, the kind of things that we write about is if there is a if we find any outliers in the data, we try to figure out why there's an outlier. And our researchers, of course, will take care of that and figure out if the look at how the sample is collected and how many people have gone into that sample, or is it in relation to other samples in the same data set as well. And we point them out if we find any irregularities there.
So I have a question which is kind of related to what you were saying. So one of the biggest issues that I find is that there's a tendency to go in with a question and then look for the answer in the data. But how can we maybe facilitate people to look at the data first and then think about what kind of questions arise from that data?
I feel like different people solve for different parts of the problem. I think we at Data for India, like I was also talking about, usually don't solve for that part of the problem ourselves because we realize that our work might not be best equipped to do that. We feel it's more important to make someone understand the data, the actual problem and the context first before you are able to engage with data. For something what you are asking, maybe like a researcher might be more, our writing team does that like internally as a process, but as an external communication we might not feel that it's the best way to do it because we feel to be able to actually advance adoption of information, you need to understand it first.
Anybody else? Questions? Yes.
Thanks for the talk. My question is about the public data that you typically analyze. Now, when I take something from NSS or NFHS, usually when I try to do some summary stats on it, I'm very wrong. I'm very off because I haven't understood maybe the multiplier properly and so on and so forth. And so over time, what I've done is I have learned to look at the fact sheets that are released with the data and see if they correlate. But I can never get it right. It just grows from a large error to a small error. The error is never zero. What's your advice?
Okay, so this is something we always come across. It always happens. Past working experience definitely helps. So I'll give you an example with the recent HCS data that was released. When it was released, we started working with the data and then comparing it with fact sheets, like you said. But we found out that the MPC that they reported is not same as what we got. And then we categorized all of them first and then compared them again. And whatever was matching, fine. Whatever did not match, we tried to subtract each of those and see if those numbers are matching. Yeah, because that happens because those kind of things are not usually documented anywhere. We only figure that out. And the next time we work with HCS, we know what to consider and what to ignore. Yeah. Yes.
That's all the time we have for questions. Thank you so much. Please, a big round of applause for Pragnya and Arpit. Next up, we have Kaushik talking to us about his city of Pune and the tree cover it has. Kaushik, the stage is yours. I'll start a 15-minute timer there. That includes your time for questions. HDMI is here.
So, am I audible? Yeah. So, hello everyone. I'm Kaushik. So, I'll just start off with a story. So, it all started with a pain. What was the pain about? It was about 7 trees being uprooted in my street by the electricity board people because they were just too lazy to prune the branches. So, they just took a bulldozer and they just uprooted it. But what was more painful was that 2 trees were planted by me, which also got uprooted. But the most painful thing I feel is that when I asked my neighbor why they didn't go stop those people from uprooting the trees, he just gave me a response that cutting down 7 trees won't be an issue or it doesn't change the world. And I was so shocked by his response. I just gave him a question back saying that, do you really know how many trees are there around us? And he was also pitch black. So I took my phone, I started geotagging all the trees in my area, and I just put it on a Google Maps to find out that we have 245 trees. And then I shared this with the community, and I just asked them like, can we do something about this now? And on August 15 of 2023, almost more than 30 plus families come together to increase the green cover of the area. So the next question that comes up into my mind is, how can I help other Kaushiks to do the same? And that's when I started building this Pune Urban Tree Dashboard. Or to make it more professional, welcome you all to the Pune Urban Tree Dashboard. So we have 3 features in this Pune Urban Tree Dashboard. The first one is the telescopic view, or it talks about like the city's lens on how they see the trees. So this is how the Pune's Urban Tree Dashboard looks. And on the left-hand side, you can see a 2D map, which has all these green dots or the trees. And on the right-hand side, you can see the panel, which shows the total number of trees and the amount of carbon dioxide sequestered by these trees. And we also get a ward statistics, like each ward has how many number of trees. And also we can see how much is the carbon dioxide sequestered by the trees in each ward. And then we have a cool feature called as Know Your Neighborhood. So I always used to think like, what is the greenery that I have in my area or city compared to the city's total? So it's very simple now. We just go, draw a shape on the map, and it gives us how much trees and what's the carbon dioxide sequestered by the trees in that specific shape compared to the city's total. So this is the first feature. And the second feature is a microscopic view. Like we just get into the trees and ask, hey buddy, who you are? So this is how it looks. We just zoom up to the trees and we can just click on any one of the tree. It gives the information. But what is more cooler is that if we click on the 3D model, it just kind of gives a digital twin of the tree, which kind of shows like this. And this is exactly how it looks in the real world, like when the records were taken, the exact dimensions. We click on any tree, it gives the common name, it gives the species name, and the dimension of the tree, and how much is the carbon dioxide sequestered by that particular tree, which ward it is from, what is the economic importance of the tree, and which months does it flower, and what's the wood density. And this is the coolest feature in this urban dashboard. Imagine that you have a friend who can advise you on what quality of trees you can plant, or if you have a shape or if you have a space, he can just come and recommend like, you can plant these many trees. So that's what this planting advisor does. We just zoom up to a space where we don't see much of trees, and we just confirm it with the satellite image. We just go toggle on the satellite image. I can see there's a barren land over there, and I just go check on the land surface temperature, and I find like, yeah, the barren land is much warmer compared to the surrounding areas. So that's it. I just go toggle off the land surface temperature, and I go to the planting advisor. I go to the drawing shape, the drawing tool, and I just start to draw a shape where I want to plant trees. It could be any random polygon that I want to, like where I want to plant trees. And on the right hand side, you can see the top 3 species for cooling for the Pune. And then I just go click on Hairy Fig, and I just come to the growth profile. I say that if it has a medium height and a broad canopy, we can go next. And we have 3 cooling potentials. One is P90, P10, and the mean cooling. So this P90 and P10, I will explain it further in my presentation, but for now, let's assume it as the maximum cooling potential and the minimum guaranteed cooling potential as P10. And then it gives us the dimension range of the species and the trees, and also gives us the potential carbon dioxide sequestered by these type of trees. And we have this planting area simulation. So in this planting area simulation, it asks for 3 inputs. One is the canopy diameter, which directly comes from the dimensions. The second one is the boundary between the shape and the outer tree, and the spacing between the each tree is the third input. We click simulate, and we can see that 263 trees could be fit inside the shape that we drew. And at the bottom of it, we get a visualization which kind of shows like how much will be the cooling effect of these trees. So it gives a baseline red curve, which is a normal day's Pune's LST temperature, which we took it from the LST data. And using this P90, P10 cooling, we say that how much is the cooling potential of these trees. So how does this help? Maybe I can just think, should I plant neem trees over here or should I plant hairy fig? So this feature gives us the power of how cool, like what is the cooling potential of the trees. So coming back to the workbook, where do I get all these data from? So the tree census data, I get it from the Open City portal, the Pune City Municipal Corporation, and also from the Samaj data. And for the lands, like the satellite images and the land surface temperature and the vegetated indices, I get it from the Google Earth engine. And coming to the most nerdiest slide of this presentation is where I try to define what is P90 and P10. So bear with me for some time. Imagine that you have a tree in front of you, and then you make a 250-meter buffer around it, and you put a grid over top of it, which has 30 cross 30 pixels. And then you just filter out the tree's pixel and the non-vegetated pixels. And then you overlay an LST over top of it, and you find out the P90 or the 90th percentile and the 10th percentile non-vegetated indices. And then it becomes simple. The P90 cooling is the hottest non-vegetated or the 90th percentile non-vegetated minus trees LST, and the P10 is the coolest non-vegetated or the coolest non-vegetated or the 10th percentile LST minus the trees pixel. And I have a statistics to show here, which says that 43% of the audience didn't understand what I said now, including me when I talked about this first to me. So making it very simple, this is an example. So the asphalt road, which you can see over there, that is the hottest non-vegetated surface. And the coolest non-vegetated surface is the one which you can see behind the tree, which is on the footpath, where you can see the building shadow falling over that. So that is the coolest non-vegetated. And to remove the extremities, what we do is we just make it as 90th percentile and 10th percentile instead of saying it as hottest non-vegetated and coolest non-vegetated. And then the P90 becomes very simple. It's just red minus green, and P10 is blue minus green. So this is the stack which I used for building it. And right now, how am I trying to develop this? Is that I'm trying to include 6 more parameters into this urban tree dashboard. The first one is air quality. Second one is groundwater. And the third water is tree's thirst level. Imagine that you can visualize, does this tree need water or not, or what's the thirst level of the tree. And the fourth one is shade simulation. And fifth one is the deforestation alert. And the sixth one is the concrete versus trees. For example, I just draw a shape, and I can see like what is the percentage of concrete versus the canopy cover. And the video that you can see over here, it is the street view simulator. I thought, why can't we advance the planting simulator to a street view simulator? Instead of just showing dots on the shape that I draw, can I just simulate those trees which I want to plant on a street view so that I can get a real world sense of it without even digging the earth with my shovel. So apart from this project, I also have 3 more projects. The first one is the tree folio. You can ask me a question like, Kaushik, you got the tree census data, so you made the Pune's dashboard. What about places where you don't have the tree census data? And that's where this tree folio comes in. Very simple. We go, take a picture of the tree, just click on the tree. It will say what is the species, how much carbon dioxide is sequestered, the dimensions, and all other things. And the second one is my personal favorite. It is called the EcoPath Navigator. So imagine you have a friend who can just find a walking path for you, which has the most number of trees. And he also gives a meditation to you. For example, if I just walk by a mango tree, the friend talks to me in a meditation saying that, Kaushik, you have a mango tree on the right side. And you know what we can learn from this mango tree? To be how to sweet in our life, no matter what happens. So breathe in all the positive energy and exhale out all the negative energy. So imagine you have a guided meditation, which are narrated by trees. And the third one is a sense path, or I call it as the nervous system of the roads. Very simple, just take a phone, put it in your pocket or on the handlebar mount or on the tank bag or anywhere, and just go for a ride. It will show how many potholes are there and what is the road quality. So I'm right now working on it. It's still not as a final product, but I'm still working on it. So hi everyone, I'm Kaushik, and I'm trying to build all these things. So my final aim is to make a pocket friend inside everyone's pocket, which talks about the environmental karma that we all do by the decisions we take, and help us take better decisions, and also shows us the cost of not acting right now. Thank you.
Questions, ladies and gentlemen. Okay, question. Anybody?
It's just about the data. You said you source all of this from Google Street Maps, or?
Which one? The tree census data or the?
All the tree-specific data, like
okay. So the
heights and all of that.
Sorry. So there's a tree census data which is done by the Pune's government, and it is published in the Pune City Municipal Corporation. But I don't know whether it's publicly available. So we get it from Open City Portal and Samaj Data. So they give it as CSVs, where we have all the lat long, species, height, all the dimensions, everything.
Have you also considered something like OpenStreetMap so that it's publicly available?
For the tree census data?
Yeah.
Okay, I didn't think about from that lens, but surely I will consider about that.
Thanks.
Thank you.
Please, more questions offline. And if the live stream has questions, you can leave them as comments and we'll keep checking. Next talk is by Varuni, sorry. And she's going to be walking us through a story about Bangalore.
Can we try? I have HDMI as well. It's that side.
Extension.
present or not. Yes. I mean, no, 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 it's not. No. Can I maybe share it? Like I have shortly shared it with you. I mean, it is extending, so why not this? Safari. I don't have Safari. Ah, okay. Yes. Hello? Yes. Yes. Okay, hang on. Perfect. Okay. Hey everyone. I'm Varuni, and today I'm here to speak about Bangalore story through open data. This is basically my attempt to be able to look at Bangalore and the data that it provides through the lens of an analyst and basically get to know the city a little better. And by the end of this talk, I hope that you will also know something more about Bangalore. So before that, I just wanted to take some time to speak about data journalism and what it means to look at data from the view of a journalist and how it helps, right? So data journalism is more about just collecting numbers or crunching numbers. It's about tracking trends, verifying the claims, and investigating the patterns. What makes it powerful is basically its ability to bridge the gap between raw data and human stories, and its ability to turn raw spreadsheets into narratives which can make people actually relate to it. The second important thing about it is also its ability to be able to bring transparency and accountability into the system. So when governments or like institutions, they publish open data, journalists analyze it, and suddenly vague statements turn into evidence, right, that we can use. And the best example I think all of us can relate to is the COVID-19 dashboards that many of the institutions, they publish. For example, WHO had one, and even John Hopkins had one. Each state had one. So all of us check them. They showcase the numbers, the hospital beds, the vaccines, and we all like really benefited from that. So I wanted to do something similar with Bangalore's open data and see if we can stitch a story. So the way that I've structured this talk is take up very popular questions or facts about Bangalore and try to investigate it and look at if we can get any insights out of it. So the first one is, why is Bengaluru the Silicon Valley of India? A lot of us, including me, I used to think it's just because of the climate. But when I looked into it, actually, Bangalore's journey to become the Silicon Valley it is today, it is because of a lot of foresight, a lot of innovation, and mainly the steady infrastructure investment that we've had which spanned over 2 centuries. And if you have to look at the timeline, Bangalore was occupied by the British in around 1830, and they established the largest cantonment here in South India. And after that, there was a lot of influx in terms of the investment that they made for the infrastructure of Bangalore by the British government and by the Mysore Kingdom. In 1882, we had one of the first water supply systems, which was the Sangi tank in South India. And soon after that, we had a reservoir as well. And fun fact, Bangalore was actually the first city to get electric street lights in Asia itself. So That was also possible because of the Mysore kingdom, who basically led the initiative on this. After this, we had another milestone, which is IISE, which was established here. After that, we had a lot of people, researchers coming in, and there was a research community set up for HAL to be established here. HAL was established around the Second World War, I think in 1940s, because of the investment done by the Mysore kingdom, who thought that this is like a good investment. HAL actually that time it stood for Hindustan Aircraft Limited, where they said that, okay, there's war and having like aerospace is a really good thing. So they did that. And because of that, we had ISRO. So what I'm trying to establish here is that each milestone was because of the precedent set by the previous milestone, right? And after that, around the 2000s, we had the influx of MNCs. And I think the government here played a huge role, where they gave a lot of subsidies and tax cuts for these MNCs to be able to come here. They aggressively pursued them, which is why we have what we have today. Just to give you like a perspective, this is during the 19,000s. If we look at the major cities that we had during that time, you can see that when it comes to infrastructure, which is street lights, roads, and the water supply, Bangalore actually is very comparable to Kolkata, though Kolkata was much more bigger. So just to establish the fact that it all just did not happen because the climate is good. It is evidenced by a lot of years of consistent development that we've had. Now, the second question that I have is, why so much traffic? This is very personal for me because I've missed one flight and one train because of Bangalore's traffic. How many of you have maybe like missed a flight or a train or a bus because of the traffic? Like, yeah, we have like 4 or 5 hands here. So yeah, I wanted to explore this. And I thought the first thought that came to my mind was, maybe it's because of the population density, the population explosion, right? And this is basically a sunburst chart of the major pressure points in Bangalore. So you have like Indiranagar, Koramangala, MG Road leading. And what was interesting was that the pressure points, they were actually a few junctions or like streets. So for example, in Koramangala, the major contributors, like 80 to 90% of the traffic was coming from Sarjapur Road and the Sony World signal. And I have found a similar pattern throughout the city. And while thinking of why this is, I realized that it could have been to do something with the way that the city is structured, right? Because if we have to blame it on the population density, you also have to realize that there are a lot of other metropolitan cities who have similar or more population density, which do not face such a huge traffic problem. So for example, if you take New York, which is actually much smaller compared to Bangalore, but they also have a bigger population density compared to Bangalore, but they do not have this problem. So when you investigate further, you realize that it's to do with the way the city is structured. So Chandigarh and New York and Washington, all of them actually follow a grid pattern of how the city is structured, whereas Bangalore follows a star pattern. And when you have a star pattern, what happens is that you get bottlenecks. For example, if you look at the picture here, in a grid pattern, if you need to get from a place A to a place B, you have multiple ways through which you can get to that spot. So there is no single point of failure there. But in a star pattern, if you look at the right side, you might, if you have one common road which you cannot exclude and jump over, then that becomes a problem. And that is why we see this. We have certain pressure points. And one interesting thing to note, which I just discovered, is that there is evidence suggesting that traffic always grows exponentially. There is math proof for it. I will share the slides later. It's in the references, which is hopeful because if it grows exponentially, it also will reduce exponentially, right? So maybe if you can take away the pressure, ease the traffic at one junction, then it will lead to like an exponential decrease in traffic at the later junctions. So that is one hopeful thing. This is another correlation chart that I have for the traffic, which correlates a lot of variables. Some of them are very obvious. For example, it says that traffic volume is directly correlated with the congestion level, 0.8 correlation. Again, traffic volume and average speed are negatively correlated, which makes sense. But one thing that I want to draw your attention to is the public transport usage. So I always thought that the way to improve Bangalore is to make the transport system better, have more buses, increase the frequency with which they fly, and all of that. But if you look at this, interestingly, they almost have no to negative correlation with the traffic. So it basically suggests that Bangaloreans don't trust the public transport system, which makes sense because they are they're not punctual, and they're also not very great in terms of like sanitation and stuff. So yeah, that was one interesting thing that I noted. This is again the same thing explored, public transport and traffic volume. They kind of, so you don't see like a lot of correlation. And one more thing that I noticed was something which was very obvious, such as 40% of Bangalore's air pollution comes from vehicles, and the highest pollution was near Silk Board. So yeah, that was there. This is an analysis of the average routes by the area. The Kempegowda bus station area, the Majestic area, has the highest access score, which makes sense because Majestic is there. The least is BTM. I can attest to this because I live there and the connection is very bad. Yeah, the next one I want to analyze is the cab fare, and the availability. So they have like an inverse relation almost. So if you have very less availability, the cab fare jacks up. So this was about like the traffic and the road situation. Next, I wanted to explore the cuisine. This was interesting to me because Bangalore is like a melting pot for a lot of cultures, right? And I just wanted to see how that reflects in the cuisine and what Bangaloreans eat. So we have around 1,500 cafes, around that number. And 60% of them are private owned. They're not chains, basically. And one thing that I saw was that most of these cafes are concentrated around IT corridors. For example, near Kormangla, near EGL, and all of that. HSR has the highest number, whereas Electronic City has the least. The blue dots correspond to the IT corridors, and the red ones are traditional ones. For example, in Indiranagar, there's a lot of IT presence, but those are like artisanal cafes that are there. This might be a little more interesting. So this is the demographic. Yeah. Okay. This is the demographic versus the food type. So interestingly, 27% of the restaurants are North Indian, and which is competed by Chinese, equal distribution, and only 10% is South Indian, which is funny. This also kind of corroborates with the demographic distribution. You have like 35% of the population which is from the north, and it makes sense that South Indians don't want to go and eat or order South Indian food, so they just make it at home. And this is the average cost. You can see that Brigade Road has the best rating, but of course, like the price is also high. And you can see that less average scores might have lesser cost. These are some additional miscellaneous graphs that I have. This is with respect to the street light status, which is apparently horrible because only 22% of the city's street lights are functional. So if you look at every area, if you look at the proportion of functional to non-functional, it is either equal to or less than 50%, which is bad. There was an interesting paper on this, and it was titled "The Silence of the Lamps," which was funny. You should go and read it. And this is again the waste flow by zone, which is equally concerning. So if you look at all of them follow like an equal proportion, but what is concerning is that 50% of it is not managed well in every zone. And this again leads to clogging and whatnot, right? So yeah, I think that was my time. These are the references. Thank you so much.
One short, quick question and answer.
Question. Who is it? This guy.
First of all, like it was really nice presentation and a lot of good data points there. Just curious, like how did you collected this data and how you curated it, and what was your thought process behind it?
Yeah, curation, I mean, collection of the data is entirely like through the open source, like there was Kaggle data sets, Open Street Lamp, Open City, it was all open source data sets. And there are a lot actually, and they're pretty clean. And when it came to curation, it was just so I have lived here my entire life, but then I did not know a lot, as much as I should have known at least. So I just took questions that I had about the city when I grew up here, right? So, and I just answered them myself, just did like an investigation. And I encourage all of you to do this for the city that you are from, which I think is very nice.
Thank you, Varuni. Up next, we have Karthik giving another talk about Bangalore.
Good afternoon, everyone. My name is Karthik, and I'm going to talk about the analysis of BBMP street census data. And in a way, you can look at it as an extension of the previous talk because it was so similar. And just like her, I was also, like driven by the curiosity because I've lived in Bangalore mostly, and the trees are like one of the major things that's still keeping me in the city because I work remotely and I could technically be living anywhere. Yeah, so the trees are like a very unique thing in like from wherever I've traveled. It's like Bangalore trees are unique in way that like Bangalore actually has, when you look at it in terms of gross area, it has like much less of a tree cover than other cities like Delhi or even Kuala Lumpur for that matter. But what makes Bangalore's trees different are they are so mixed up with the residential areas. It's not like we've set up parks and or like you want tree, you go to the park. But here it's like, hey, like whenever I go out to friends, go out for lunch or dinner with friends, we just typically take a walk after dinner, and even despite the bad walking infrastructure, we are able to do that because there's trees, and it's even if you're like jumping over potholes or walking on non-existent footpaths, the trees still make walking a very good experience. So yeah, first let me talk about the data set that I use. It's from published by BBMP in 2024. And for those of you who do not know what BBMP is, you don't need to know because it doesn't exist anymore. Yeah. So, yeah, I downloaded it from opencity.in because it was supposed to be open on BBMP website, but I went there and I saw a CAPTCHA, and then I tried entering it 4 times, and yeah, I just didn't get it from there. So when I downloaded the data, it had about 2.8 lakh trees, and it had like species name, zone name, ward number, and geographical coordinates. And I'm going to stress on geographical coordinates because, even 10 years ago, if data like this was published, you would not have the lat long. And now that BBMP is gone and you have only the ward number, which is data is basically useless. But now that we have the lat long, like even with the new administrative divisions, which if you've been reading, there's 5 municipal authorities and Greater Bengaluru Authority and all of that. So I can use the lat long to remap these trees to specific corporations and redo the analysis with any new ward boundaries that come out. Yeah, so that data was only partial. They said that 15 lakh trees are yet to be counted, and to be honest, it feels a little like, wait, who are we to count the trees? These trees have probably going to outlive most of us, and they've definitely outlived the BBMP. And yeah, for me, it's like, hey, like when you are young, you just used to collect like Pokemon cards, or if you like some actors, you used to have posters of them in their house. And since I like the trees, I like to have this whole data set in my laptop. And yeah, it's one of the motivations behind me doing this whole analysis. So the first thing is the citywide tree density. So with whatever data we had. So if you can see, there's hexagonal bins, and that's like overlaid on the map of Bangalore. And these hexagonal bins are what is called Uber's H3 geographical indexing system. So it's not a rectangular grid, and Uber developed the system of being able to put points into hexagonal bins, and you can do this at multiple levels. So like each index, the hexagons are going to get bigger or smaller, and there's a whole bunch of resolutions that you can use. And the advantages of using hexagons is that, like, when you take a rectangle, it has like 4 neighbors sharing an edge and 4 neighbors sharing a corner, so 8 neighbors in total, and not all neighbors are equal. But when you take a hexagon, it's it's like there are 6 neighbors to every hexagon, and they're all equal in their status of being a neighbor. And it's just easy to visualize the neighbor effects and so on. And if you can see the data itself, you see like some green spots around what I would say is maybe Jayanagar, Banshankari. So that seems to be the most densely populated with trees, and there are like some spots here and there. And this is one more redundant map because I did this way back last year, but even then it's kind of useful to see what's going on. So this is from the 8 zones that used to exist in the BBMP, and as you can see, I think the darker color means more tree density. You can see that south and somewhere in the west, the tree density is more, and I think one of those zones didn't have any data. I mean, definitely, it doesn't mean that there were no trees there. We just don't know. Like, maybe they didn't bother to go out and do the census, or I don't know what's going on. So, and this is the data in terms of numbers sorted by, like trees per square kilometer. You can see that South and Rajarajeshwari Nagar are like the more. And I used to live in Rajarajeshwari Nagar for a while. Like, here it's a zone, but I used to live in the locality, which was also a part of the zone. And the residents there were like, hey, we had like a WhatsApp group for, protecting the trees. So if anyone was like suspiciously standing next to a tree with an axe, there would be a mob within 10 minutes. And I think that's the kind of, activism we need. Every city needs to protect its trees, especially if the government doesn't care enough. And okay, now let's get into the tree species itself. So the BBMP had undertaken, like they tried to identify tree species, and how well they identified is evidenced by the fact that the second most popular species is called others. Okay. Yeah. So okay, jokes apart, the first one is Pongamia pinnata, also called honge in Kannada. I don't know if most of you might have heard about this in your environmental science textbooks, I think, when you were growing up in the early 2000s. There's a lot of research going on where they're trying to extract biodiesel from the seeds of this tree. So you might have heard about this tree in that context. And there's also American mahogany, rosy trumpet, and Ashoka tree. And yeah, and the Ashoka tree itself is it's one more like common tree. And I remember my great grandmother, who was like not great grandmother, sorry, my grand aunt. She used to live alone in this house, and they had like 2 Ashoka trees in the front yard. And I was like, hey, COVID is coming, you should be like, keep yourself safe, wear a mask. And she's like, no, I have the Ashoka tree. I don't know if that made sense, but that's the kind of attachment people have with these kind of trees. So yeah, here's more trees. And the other one I distinctly want to talk about is the rain tree. If you've seen those huge trees with like a big canopy, and I think every March or so you have these pods falling from these trees. And when we were young, we used to like collect these pods and mash them up, remove the seeds, and we were able to roll them, and it used to become like a ball. And it used to be so hard, like harder than a cricket ball. And we used to use that for training for cricket matches, because all because we couldn't convince our parents to give us 5 rupees to buy a tennis ball. And okay, let's go with the zone-wise tree distribution. So this, again, we can, if you want, we can play a game. Like there's one tree in the background and top 3 trees. So you can all, if you want, you can guess which of the 3 trees that is. So, and I might have forgotten the answers really, but anyone wants to go for this one? Yeah. I think this one is the American mahogany in the background, and this is the Bomanali zone. You can see, and I've put the count also. And in the east zone, we have again honge, Nile trumpet, and American mahogany. The one in the background should be Nile trumpet. And here's probably the most favorite one of, how many of you have seen this tree? Yeah. This is like the spectacle that happens every February, March or so. And we usually compare it with Japan, but like the cherry blossoms. But in fact, the cherry blossoms in Japan and that part of the world and this particular tree, they are actually like different species. They just have pink flowers and they bloom at that time. So this one is the rosy trumpet. And and a fun fact is like there's a German botanist who kind of planned which tree has to be planted where, and he planned it such that at any given time of the year some or the other tree is flowering. So like every season there is a tree flowering and there's some color for you to see. And despite how gloomy the city is, like the city is gloomy for half the year, and if not color in the sky, you'll at least see some color in the ground. And this is Rajarajeshwari Nagar with the honge seed in the background. Again, this is south with one of the common trees is the MacArthur palm. And I don't know, I think all of us have a mixed relationship with palms. Like, they're probably not native trees, and they're like ornamental, and some people get like really protective about them. Hey, stay away from my palm tree, don't play cricket here. Yeah, so, and this is west. So again, we've seen these trees before. It's honge, American mahogany, and Ashoka tree. And I think the west gets a little bit more wild than the south. Like as they say, the west is always wild. So west is, like where, Magadi Road and all of those sides, if you've been there. And then there is Yalanka. We see some new trees here. Like there is the gum Arabic tree, which you can see in the background. And Yalanka is in the north, and it's actually a drier area. And if you actually look into Bangalore's geographical classification, like most people would describe Bangalore's geographical area as semi-arid. So what that means is like most often when you leave the city, you will find lesser trees than what's inside the city, which means that a lot of the trees in Bangalore were not like naturally there. It's all because of human effort over many centuries that these trees are there and we are able to enjoy them. And that's what makes it more important for us to, you know, like at the least leave it behind, and at the best make it better for the next generations. And yeah, let's coming to the unidentified trees, yeah, or the others, which wards had the most other trees. So I think Yalanka tops the list with like 72% of the trees being unidentified, and Mahadevpura is again 31%. That's where all the IT stuff is. Sorry guys, but yeah, I think all the others are like decently okay. And yeah, here's the conclusion is first is thanks to OpenCity for somehow managing to get the data from BBMP's website and putting it there so that I could get it. And even the BBMP zone boundaries map, I could get it from there. It's just much easier. This again, the census is far from complete, and the body that was taking up the census is no more, so we don't know what's going to happen. But there is updated data, and there is lat long for each of these, and we will have the new administrative boundaries very soon, so I can hopefully redo this analysis with the new boundaries. So yeah, that's it. That's my time, guys. So there's the QR code for the blog post and the code used in the GitHub report.
We're gonna skip questions. They're running a little late on the Devroom, so we're gonna skip questions, but do take questions for Karthik offline. Next up is Adhavan, and he's gonna be talking about his work in making political archives accessible on the internet.
Timer is visible here?
Yeah. You have the display over there as well. That will mirror your slides, so you don't need to turn back.
Okay. Hi, this talk is not going to be about Bangalore. There will only be one mention of Bangalore. So hopefully people tired of Bangalore being mentioned. The original title of the talk was Making Political Archives on the Internet, the Constitution, Hate and News. With some reflection, I've decided the talk should be titled Making Political Archives Outside of the Internet, the Constitution, Hate and News. My hope today is to leave you all with a curious desire to engage and make with the political internet and outside the internet in other languages, to do it together, to hopefully find community and company to do it together. I'm Adhavan. I'm a technologist of sorts, working in place-based social contexts. I work with Arora and Living Labs Institute. And we work across Karnataka. These are on the left we have a 1,000-year-old stepwell that we're working with. On the right we have the grasslands of Bidar. So what I mean by
accessible and what I mean by political are some things that I'd like to define right here. When I mean political, I don't just mean formal politics, but also conversations, dialogue, thoughts, discussions, and events that make up the politics of the present. And what I mean by accessible is going outside of our circles. Our circles could be the internet, our circles could be English, the language, our circles could be anything that we're very comfortable with. And I think we have to make very active efforts while doing work like this to go outside of our circles. And that is what I mean by accessibility. When I mean accessibility, I also mean coming up with ways to use common languages that are understandable across broad paths of our neighborhood, our country, our city, our state. And a good example is if you look at political symbols that we use in the country, they're very common icons or events or occurrences that are very commonly understandable. So when I mean accessible, I think you can think of these kinds of things, which are understandable by people across language, education, culture, context, geography. I'm going to be talking about two works through which I've come to understand the political present. And my introduction to both of these works, one of which is the Where Does Hate Live platform, and the other is the Constitutional Observer, began with social media accidents. There's a lot of history that I did not know. I was a post-2000 born, and I was born into a time when not much of the pre-2000s is being discussed in terms of political history. I came across videos like this on Instagram and on Twitter, and when you see videos of people and men being lynched and sort of begging to not be hurt and fought with, they're being lynched solely because there's an assumption, a prejudice, an opinion that they were carrying cattle to be slaughtered. And you'll find many of these videos on the internet. And I did not know what made this possible. I'm a naive college student at this time, and I'm thinking, what makes this possible? What is the political environment in that place? What is the culture? What is the people? And I'm privileged enough to be to have gone to school and to have grown up in a context that's not so immediate to the context of these videos. I did not know much of what happened in 92 or the events leading to 92 with the Ram Yatra. I hope the Ram Yatra. I hope people can recognize what scene this is. I can see I can see a age distinction in people who are nodding, and I've seen this in my friend group as well. I did not know what sort of events led to 2002 in Godhra. This is the year I was born. But of course, it's only the everyday that leads to events like this. There are very small events that happen across time, space, geography, and political circles that lead to these larger events. But standing in 2025, we only see and remember these large instances of, or at least when I attempt to understand these in the past, I see these two big events, but I don't know too much about the everyday happenings. So this context is with which I wanted to understand the present. So what happens in the everyday that leads to bigger events like this that still happen in the country? And that led to the work of Where Does Hate Live? I've been working on this for 2 to 3 years now. Where Does Hate Live geolocates and displays an archive of violent events, speech and misinformation, and more forms of hate. it's meant for a person to be curious about where they're from. You know, you're from Chennai, you're from Bombay, you're from Kolhapur, and you go near your place and you attempt to understand what kinds of violent events are happening in the place around you. And then from there, what are the relationships you find in those events to events next to them? So for example, I'm from Chennai. I'm curious about the kinds of events that have happened across the last few years. I come across this article, unique initiative of Southern Railways to transport livestock runs into Gaurakshaks, 28 May 2017. So it's at Indian Railways, South Railways train going from Maniambadi, I think, and goes to Assam. And there are Gaurakshaks waiting in Assam who assault the driver, the veterinary caretaker, and they take the cows. And this makes me curious to see what kinds of events have happened in the railways as an institution, in the railways as a geography, in railway tracks, in railway stations, in the Indian Railways as an institution, which might or might not perpetrate, or I don't want to say perpetrate, but allow such events to happen. So my search was railways in the south of India. One of the first few reports that come up was train with NEET students from Tamil Nadu delayed by devotees offering namas, 2018. This is a fake news that was fact-checked by Alt News. This archive contains geolocated events from Alt News and Hindutva Watch. Alt News is a disinformation and fact checker that you might have come across, all of you. Hindutva Watch is an aggregator of events that they consider to be Hindutva, violent forms of nationalist agenda. They also go far beyond news. They also collect social media videos, which is one of the videos I'd come across that led to this work. So from NEET students, I come to this article. It's in coastal Karnataka and northern Karnataka. The report says, violent Hindutva is not a problem in coastal regions alone. It references a person who was murdered and their body dumped on the railways. But the focus usually in Karnataka is on the coastal, south coastal, Dakshin Karnataka region, and not in North Karnataka. This is the only reference to Bangalore. There is a news report of Indian Railways giving blatantly propagandist newspaper, the Aryavat Express, on the Bangalore-Chennai Shatabdi. So this gives you an idea of how I can inquire about the railways as an institution that allows or has been the place for such violent events to occur. Hindutva Watch is the website and archiving platform that showed me some of these videos. It's from here that I wanted to see the relationships between these events, in the actors, in the political parties, in the kinds of violence that happen across time and geography that led to the spatial form of the Veda Settler platform. And they document more than physical violence. It's also, these are softer forms of agenda. There is speech, there is lawmaking, there is all kinds of smaller things that happen in smaller scales that roll up to be the bigger ones. This is Zubair. People who are on Twitter might have definitely come across Zubair on Twitter. He is one of the people who actively works in Alt News. This was possible by accessing their archive. You have to detect the locations, you have to geocode them, you have to display them. It was very easy to access their databases because there's a WordPress API that both of them use. There's over 10,000 events on the map. LLMs were okay-ish at placing them on the map. Now, like these are not always formal political events that are not on the map. It's not always formal political actors that create or initiate or take part in the events that I've shown on the Vedasirlu platform. So I'm curious what makes this political mahal, this environment within which something like this can happen. And this is something that we have to see across decades and half centuries to understand what kinds of lawmaking and policy and conversation in formal spaces have led to us being able to experience these in non-formal spaces. And the other thing I came to realize is this archive, the Hindutva Watch archive, also documents movements against hate, protests, statements of people standing up. So how do we see these efforts to stand up, and how do we see through them the political mahal that exists now? This led to the work of the Constitutional Observer. It's a comparative interface for understanding what the discourse surrounding a topic has been in the Lok Sabha currently and in the Constituent Assembly, which is the assembly which made our constitution between 47 and 50. So for example, I ask a question, whose travel must be taxed? And this is Mahavir Tyagi saying 1949, October 16th, in the Constituent Assembly. The state renders no free service to the people except a few dozens of quinine mixtures mixed with water. Doctors charge their fees, treat the people on payment. The state is not actually rendering any free service except that we are giving our citizens a psychological satisfaction to enjoy in their belief that they're a free people. And I asked the same question, similar question, who must get the most taxes? And I get these few responses from the Lok Sabha. So this is 1996, 2012, and 1994. My favorite, the biggest sufferer, I'm sure Shri Vajpayee will be very happy to hear me, are the people in the rupees 3,000 to rupees 7,000 bracket. This is one section of the society. A poor man, whether he's earning 500 to 1,000 or whether he has something less or more, he can manage. He does not have any social hang-ups. He does not have any reputation or expectation to live up to. Whereas a person in the bracket of rupees 3,000 and rupees 7,000, you can see where the argument goes. And you can see that this is being said in the Lok Sabha. This was possible because the Lok Sabha, the Rajya Sabha, the state assemblies, most of them have websites that document everyday debates. Now, the Constitutional Observer was never meant to be just a website. It's meant to be something that pokes at your curiosity. Because the thought here is to not make a website that allows you to search. It's not an archive alone. It's meant to make you curious. If you're not already curious, why would you even be interested in the archive? So it's actually meant to be an exhibit of questions like these. Who should the nation pray to? Who should the nation pray to is a very funny question, very naive question. It assumes that the nation should pray to somebody. It assumes that the nation should pray to a singular somebody. And the exhibit is made of more such seemingly naive questions. Questions like, who should feed us? Who makes our food? Where must our cows graze? What should we eat? What can we eat? What can we afford to eat? Who must feed our chickens? Who must feed the economy? Now, these questions, when you read in a series, which I've noticed in people who come to public exhibits, have made people who are not necessarily directly interested in large political questions become very interested in the politics of very everyday questions like, what can we afford to eat? Who must feed the economy? Who must the economy feed? These are photographs from an exhibit outside Vidhan Saudha last year, where sadly the questions are all in English. But even though they were in English, there was a very wide and diverse audience who had come to the Democracy Day celebrations last year. And these are English-speaking students. There are Urdu, Hindi-speaking students, Kannada-speaking students, and there are older people who can only speak Urdu, Hindi, Kannada. And you see these students translating and communicating what it is to the older people who don't need to, who don't or read English. And the people then wrote these questions. So you can see that there's a certain curiosity that was spurred in it. So the intent of the observer is to make people become more curious in more accessible ways than just solely being on the internet. This is a photograph of the questions being exhibited at Kavan Park. If you can see the khaki pants and the leather shoes, we were asked to leave Kavan Park because this event was organized in memory of Gauri Lankesh. And we had not asked explicit permission, but apparently you don't get permission for events like these. And we were asked to pack up. Much of this was inspired by the work of Reclaim Constitution, who you might have come across in Bangalore, in public spaces, in public events, in schools and colleges. Now, the Constitutional Observer doesn't give you direct answers. It's not an LLM. It doesn't synthesize and give you answers. It's meant to give you direct excerpts so that you directly access the material and you read it. And it's not always great. It's not a perfect model. I'm not a software engineer who could build such a thing. So it gives you very funny answers sometimes to some of the questions you ask. So it's enabled by a text embedding, which tries to make relationships between similar things and farther things are put farther away. For example, cows can be brown, animals can be brown, some animals are impure, are all closer things in context than paper can be colored. The Lok Sabha text archives had to be parsed from PDFs. The PDFs are very difficult to parse, especially going back a few decades. So that's why you see many artifacts in the small apostrophes, random spaces, things like that you'll notice. Now, coming back to what I said at the beginning, that we must hope to make these kinds of work more accessible. I'm thinking of what our closest circles are. To me, I have not gone beyond English, even though I could probably work in Tamil. I have not made so many efforts to make outside of the internet and participate in public speech in public areas. So, and all of us have these kinds of circles that we sit within. We make our work, especially work like this, work with a political context, in context that we can make work in. And I think that's because we are very singular in the efforts that we do. In my few years, in the people I've attempted to work with, and attempted to collaborate with, it's been difficult to do that because it's a constant negotiation of who has the time, can you collaborate with somebody, can you collaborate with this organization? And it just never works out. And that's why I said at the beginning that we can hope to make these as part of communities and with collaboration. Now, I don't know what forms this can take outside of the internet. One instant thing, one direct thing that me and Vivek here have been trying to do is to start looking outside of the Lok Sabha and the Rajya Sabha. Because for some reason, state assemblies are not reported on as much as Lok Sabha, especially in English news. If you're an English news reader, you'll most probably see more Lok Sabha reportage than from the Karnataka State Council or the State Assembly or the Tamil Nadu State Assembly. So we've been trying to archive the State Assembly records. So we've so far got into archiving Tamil Nadu, Madras Presidency, Karnataka State, Kerala. So this is on archive.org. So This is an example of a search for Veerappan. I assume that most people here will know Veerappan. So you search in the records for Veerappan and you get references from the Rajya Sabha, you get references from the Tamil Nadu State Assembly, you get references from Karnataka. And this is an English text term. So the idea is to, like, the direct idea that we're trying to see is how can we get other state assemblies together and make these accessible in their own languages to people in their own states. I'd just like to end with this slide that I put a lot of thought into over the last week on how to communicate the idea of what is accessible. I hope we think of forms that are not about being exciting for us, but forms that are more accessible to people. And that's it. Thank you.
How many questions do we have time for? One.
Okay. I don't have a question. I just want to compliment the nature of the talk. I think it went into a lot of different directions, but also like the aesthetic of what you tried to do with using the drawings, etc. Like I thought it was such a great balance of the left and right sides of your brain. So thank you for that. And really the depth of it. Thank you. Would love to talk offline. Thank you.
Question.
Yeah, so you have talked about other state assemblies, right? So I just want to know your views upon the judiciary. Like some of the cases affect the future perspective.
Yes.
So I just wanted to know, how do you think, probably?
I think Vivek. Am I audible on the mic? Okay. Vivek has already started archiving, I think, High Court records on the same archive. So if you go to the link here, archive.org/details Parliament of India, you get parliamentary records. You will see related collections there, and you'll see the High Court records there as well. And I think one reference here is actually from High Court in the previous slide, but you can check later.
Next up is Saurabh, and Saurabh's going to be talking about disaster management and open data.
Thank you. Hi, can I? Okay, I'm audible. Sure.
I will give you 15 minutes, that includes your question time.
Yeah, sure. Okay. Okay, so hi everyone. I'm Saurabh. I work with an organization called Civic Data Lab. And I'm here to talk about one of our projects that we developed, which is essentially developing a flood data ecosystem for disaster risk reduction. It's a project called IDS-DRR. It's a bit of a mouthful. Essentially, so Civic Data Lab is a social enterprise. We're focused on basically enabling data change makers to leverage data and AI to drive social good across India and across the world. We work across a number of pillars, primarily in public finance, digital public goods and infrastructure, few others. And today I want to talk about one of our projects, which is more in the climate action sphere. So I think living in India, we all know about the issues of climate change. That primarily one of the biggest problems is with hydrometeorological disasters, especially flooding and cyclones. But this problem is compounded by the fact that there don't exist good data resources to enable effective flood management measures and risk mitigation strategies. And just taking examples of from how we work on the ground, this is looking at one of the states we work in Assam. Essentially, this is how data is stored. It's in boxes, it's in files, it's existing in silos in different departments. And essentially, data is not talking to each other, and it's hard for departments to work together to actually come in on the ground and develop the capacity that they need to actually address disaster-related issues. So this is kind of where we jumped in with our project. It's called IDS-DRR, or the Intelligent Data Solution for Disaster Risk Reduction. So it consists of 3 components. One is a climate data exchange. So we have collated data from various different sources and transformed it, cleaned it, so that it can be used for climate action more effectively. We've also developed an AI model for risk assessment, which will help authorities in the state disaster management authorities actually identify geographies which are at risk and be able to prioritize resource allocation in those geographies. And we have also modeled our platform around the Sendai DRR framework, which basically there are a few components. One, it looks at risk as a component of sub-factors. One is of hazard, which is the geophysical properties that result in a certain disaster. Then there's exposure, which is the population and the assets that are exposed to a disaster. And there's vulnerability, which looks at socioeconomic vulnerability, as well as losses and damages and infrastructure access, and a number of different aspects. And finally, government response, which is looking at what sort of resources does the government have to actually to respond to a given disaster. And through this methodology, we want to move the focus in disaster planning away from impact management to actually long-term capacity building and preparedness. So I can show you our platform. This is, hopefully it's visible. Yeah. So it consists of an analytics layer. Essentially, you can dive into different geographies and yeah. So in this case, you can see that Sivsagar looks like the overall flood risk is very high. You can dive into Sivsagar, see what factors are contributing to flood risk. In this case, it's government response, which indicates that maybe they don't have the funding required to actually respond to a flood situation. So you can dive into that. And yeah, it seems like they don't have flood tenders. They don't have state disaster relief funds available to respond in a given situation. And similarly, you can dive down at the district and sub-district levels to actually understand what sort of factors are impacting flood risk. You can also do a sort of time series analysis, again, taking Sivsagar as an example. You can look at overall flood risk. You can also compare risk over months, etc. So there are different modalities you can use to actually analyze the data. And finally, this is the flood data, the ecosystem that we've developed. So all the data is actually accessible on the platform. You can go in and both the transform data as well as the raw data that we've scraped from these platforms. You can go in, analyze it, see whether it fits your needs, and essentially we really want other people outside of just the state disaster management authorities and us to be using this data towards public good. So please feel free to access it and do what you build use cases around it. And again, all the data and all the scrapers, everything is accessible on GitHub. You can dive. This is a repository for Assam. We also have similar repositories with the other states we're working with in UP, Bihar, Himachal Pradesh, and Odisha. So this includes both the data that we're using into our platform as well as the scripts to actually access the data and analyze it. So there are a number of use cases. We think especially our tender scraper would be very useful in different contexts to understand what different public procurement practices. So please do feel free to use it and fork it for your needs. So yeah, just kind of giving an overview of what the flood data ecosystem is. We kind of we mostly work with governmental sources, and it's a range of one-time and monthly sources. We typically update the data model on a monthly basis, so that's the kind of resolution we're working with. And we're looking at one of the main data sources is flood-related funding. So just kind of giving you an example of how this works. We extract data from we scrape data from the JEPNIC portals, the e-tender portals of every state. We extract indicators from these data sets. We develop a risk score for each sub-factor. And these are all combined using a TOPSIS model into a cumulative monthly risk score. And this essentially is the structure. So we're looking at various different features from geomorphological data, population and demographics, infrastructure, and losses and damages, which isn't in the public domain, but we have to work with the state disaster management authorities to actually access this data. And we build MOUs around that. So can I just talk a bit about some of the challenges we face with data? So no, this is like just a abstracted version of the pipeline. One is actually accessing the raw data, cleaning, extracting the indicators, transforming it to the relevant spatiotemporal resolution, at which point we get the monthly and sub-district level data, which we then feed into a risk score model. One of the biggest problems, as you know, working with government is just accessing data. And for us, the biggest way we could actually get around this was developing relationships with the disaster management authorities and with key people in the government who would actually champion our cause and help us actually get access to the things we need. And another key factor here was actually the existing open data ecosystem that we were able to gain access to. So there are data sources such as WorldPop, Sentinel, etc. And we could access these open data sources to create a pilot of our disaster risk analysis platform. And this was very helpful for the government themselves to be able to see that there is value in this data sharing process. Like if we just went in with the request, we would probably get dismissed right away. But then I think going in this manner actually helped us get a lot more access. And also identifying champions. This could be in any level of the government. It could be in the highest level. For example, in the ASTMA, we had the CEO himself actually championing a cause and taking us to different locations and helping us get MOUs. But sometimes even if it's more the middle management of the government, they can kind of help us get those key meetings and build up those relationships in a softer manner that actually helps us in the longer term. Finally, another big issue we're facing is often with just the methodology that we're using for analysis, because we kind of work on an iterative process where we're showing the data, the results of our models to the ASTMA, trying to get them to validate it, and so trying to build that level of trust where they also understand the insights and understand the modeling methodologies that are being used was a bit of work. We had to make sure that it was easily explainable, that it wasn't just this black box model that they don't know what's going on with it, and it was easily explainable to them. Another thing is in ground truthing. How do we know that the data, the insights from our data model are actually making sense and lining up the reality? Unfortunately, there's no clear way to do this right now because there aren't exactly risk models that we can compare against for these very localized contexts. So in this case, we again have to work with the state disaster management authorities at the district level and just go to them and ask them, does this line up with what your expectation is? Is this sub-district of yours actually facing this level of flood risk? And is it these factors that are contributing it? So we kind of have to do these exercises for validation. Yeah, and I think one thing that has helped us also is a more sort of iterative process where we're constantly we're building basic models. We're showing them to the authorities, getting their feedback, and having these consultations, which helps to kind of build it up into something that's more usable in the long term. We also try to cater to their custom requirements in different cases. For example, but this iterative development also helps because in the case of Himachal Pradesh, we weren't able to get access to key losses and damages data. So we had to kind of keep coaxing them, to try to get API access. They weren't able to do that. Then they finally gave us a data dump, which was completely unusable because we did not know which disaster certain types of damage were associated with. And finally, they just got so frustrated, they just gave us back-end access to their server, and we were like, okay, this doesn't seem like the best idea, but it's getting our work done, so yeah, great. But yeah, that's it. This iterative process kind of helped us identify what works in each given context. So yeah, all our data sets are platform. The technology is all open source. They are they're shared in various open source licenses. Data sets available are in either in government or open source licenses or CC by SA. We typically sign MOUs with the disaster management authorities for sensitive data access. We try to remove any traces of PII, and all data is anonymized before it actually feeds into our risk score models. And yeah, in terms of impact, we have launched a platform in Assam, and we have trained over a few hundred decision makers across different levels, from district and state levels. And we are trying to see how this kind of platform can be institutionalized for more long-term disaster-related planning. As an example, this year we helped to allocate about 100 crores of SDRR funding within the state. We're hoping this can kind of build from there. While we primarily work with secondary data sources because we want to draw value from existing public data sources, we do see there's a major need and a gap currently in terms of citizen reporting and the kind of data that's actually, that this is something that's not being tapped into. So we're trying to develop a citizen engagement chatbot, which would allow, on one level, also real-time alerting based on disaster needs, and also would allow citizens to report what their impact is on a more granular basis, and also maybe enable more detailed post-disaster needs assessment data sets. And yeah, we're also trying to expose into a more into different geographies as well into other hazards. We're working very closely with in trying to develop heat action plans with different states at the moment, and diving more into urban heat island analysis as well. And sure, I mean, we would love for people to just contribute to the data sets and to the platforms that we've developed. So please feel free to just access it and yeah, contribute as much as you can. We also have a number of articles about some of the scraping methods that we've developed and some of the tools that we developed. You can dive into those, and yeah. Thanks. That's it for me.
So you have a flood prediction model and it gives you a risk score and all that.
Yes.
So recently there have been a lot of floods in different parts of the country. Have you seen your models predicting these correctly?
So we've not, we do work in Himachal, and so just one slight clarification is that we don't actually do flood prediction. We work with historical flood information to generate these risk scores, because that's what ended up making more sense towards long-term preparedness. But there is some level of validation. We haven't really developed models for states like Punjab and Jammu as yet. But in the case of Himachal, we are actively validating it with SDMAs.
Okay, just one more follow-up question. You're building a lot of data pipelines and all. Are there like standard data models or points that you're trying to collect when you're expanding it to multiple geographies and stuff like that?
Yeah, so we kind of have just in order to enable us to be able to scale it into geographies more, but we do kind of have like a baseline version of our model that consists of a certain set of data sets that are in public access. So we do have a sort of a baseline model that can be easily ported into different states. This consists of procurement data, the flood inundation data, some of the more basic data sets that are available. But then we try to go deeper as we start working with the state disaster management authorities. Okay, thank you so much.
Up next, we have Sai Krishna, who will be talking about AQI datasets of India.
Another disaster, something which we face every day. But it generally becomes hard to speak in Bangalore about this topic because it rains every day. We had a good talk on trees, so generally get we feel that we are breathing good air. But thanks to, forgot his name, anti-aging guy, for wearing the for wearing that mask and in Bangalore, so that I can now speak about this issue much more confidently. Okay, so I'm Sai Krishna. I'm working with urbanemissions.info as a research associate over the last couple of years, and primarily I work on the data front, opening data sets related to air quality. Some background related to air quality related data sets. There are three sources. We focus on monitoring data, which is what your AQI monitors. CPCB has few monitors in India. All the data collected by these monitors is the monitoring data. And then we have satellite data. Tropomi is one major satellite that is on India, and we collect data from that. And then there is physical models, model simulations, and outputs of those models. We also use that data for forecasting and other needs. But today I'll just speak about the monitoring data. This is how a monitor generally looks, and three basic information points that we can get from a monitor is what is the amount of pollutant concentration at that instant of time. In India, there are two different kind of monitors. I'll go into it. We get data at a 15-minute interval. So where is that monitor will give us the location of the pollution concentration and the time intervals. And one major issue with monitoring data is, which generally media also doesn't consider it when they report it, is that each monitor just represents an area of this 2 kilometer radius. 2 kilometer radius area is what it represents. So generally when the media reports it, it doesn't take this point into consideration. And as a result, if your city has very less number of monitors, it means that the AQI value that the media is generally reporting for that city is not a representative value. Yeah, I'll just start the major point. So there are two kinds of monitors. One is called CAA-QMS monitors. Like these are continuous air quality monitoring stations, which give data every 15 minutes. There are about 500 monitors in India. I think Vivek, Matthew, yes, he already cleaned this data up and put it on data meet. I think that data is set at hourly frequency. But we also have something called manual stations. So the manual stations give data, like what is considered as a manual station is it for at least 103 days in a year, if it can give daily average AQI value for the city at that point, then we consider that as a manual station. And there are about 800 manual stations when we last counted it, but the numbers wouldn't change much. And we saw great increase in the number of cities having monitors, but as I previously mentioned, most of the cities, like about more than 200 cities, have just one monitor, and media reports the AQI value of that one city as the of that one monitor as the average of the city, and which means it's not really representative. We are only speaking about one small box in that city as representative of the entire city. And there are only few, like about 15 cities that have sufficient, decent representation with respect to AQI values. And an estimate that we need about 4,094 monitoring stations, and we are very short of that. Nevertheless, we have what we have. So from 2015 onwards, we scraped some data. So CPCB publishes something called daily AQI bulletins. Every day we get a PDF, favorite standard of the government. So now this data set probably was in Excel first, but then they had to convert this into a PDF. So they converted into a PDF and they publish it every day at 4 p.m. This is the AQI bulletin, official data daily reported for all the cities that has a monitoring capacity. And these variables are very important for us. Like one, we have city. We have this AQI values. The third column is the index value. And what generally media reports is the air quality categories: good, satisfactory, very poor, etc. So we have that important column. The most important column for us is the prominent pollutant. Is so on any given day when we calculate AQI values, one of the many pollutants will drive the AQI value. So that becomes important for during the analysis. And also, not every station in that city is operating on that day. So we also get an information of if there are any in cities, like what is the percentage of monitors that are not working on any given day. So this is the data, and we scraped for the last 10 years, did some cleaning with OpenRefine. I think that tool saved my time a lot. Got to know about it very recently because the city names would. This is a. I'm happy that they started doing this. Aurangabad, Bihar, and Aurangabad, Maharashtra. Because in the previous years it was not the case. It was just Aurangabad, and I mean I had to delete few rows because I don't know which state that Aurangabad belonged to. So, but it's improving. But OpenRefine really helped me clean these things in a better way. And then I started putting it on Datasette because when I was applying for this talk, I thought putting it on Datasette would make it easier for me to get selected. So I put it. But otherwise, it really helped us with respect to like showing the data. Public, like I learned a lot about Datasette while I was doing this, and it enabled us to actually show our work to many more people, share work more easily as well. And like just people interested in Datasette, I'll just show this facets option. You get a drill down version of your dataset that you publish. And if I go into Delhi, because that's where most of our stories are, we go to Delhi, I see that, okay, this is the number of rows basically for each of those categories. I can see that there are about 164 severe days for air pollution. I'll click that, and then I'll see that, okay, most of those days are in the months of November, December, which is obviously that we have days when you listen to a lot of pollution stories from Delhi as well. Stubble burning is just one of the reasons, but yeah, many other reasons. So like this dataset feature, I'll show other thing which we really liked in this. Then what major aspect of working with this was also that, okay, we got the data, started publishing it, but what I really liked is if you spend more time with any data, and it can be small data, it need not be big data per se, and that's kind of the theme of like the open data Devroom also, which I liked, is that if small open data, but if you really work with it, spend time with it, you will find some stories in it. And as I spent more time with this data, as you see, it just has 5 columns, and just, but I could develop a lot of stories. I could tell a lot of stories when I was working with this. So it just yeah. So just to start with basic visualization of it, we wanted to see what are the prominent pollutants more visually. So if I want to see, okay, on which days carbon monoxide is actually the prominent pollutant that I'm breathing, like, so I can just so develop small visuals based on that. And obviously these are the days when pollution is generally low, because again in those months Delhi, it rains well and pollution is less, but still because the particulate matter has reduced, your driving pollutant has become, like carbon monoxide has become the driving pollutant. So this one, just looking at the PDF, we would like I would not have found that so easily. So visualizing these things helped me just pick those insights from the data. So this was our first work that we could do with this data. And then like one of my greatest sources of data is media itself. So there's always that battle that happens. I read something which I feel like, no, this is not, you are reading the data wrong. And my preview of working with this data more closely, I just get to analyze this better. So this recent July, this news was famous that Delhi really saw a very clean July with respect to air pollution, and the government claimed that, let me find that. Yeah, true determination always delivers visible results. And I was like, let's check that true determination. So we started doing like again, how do you test these things? My only tool is statistics. So I read this book called Art of Statistics just the day before I read that news, and there's one chapter in which he analyzes just using random variation in the data. Can you test such claims? So we saw that, okay, Delhi's AQI data, average AQI data which the claims were on, kept varying. There was this random variation across the years. So we really cannot claim that there is systematic change with respect to government effort or anything. It's just that probably trained more, and that was what the story concluded to eventually, that it rained more in Delhi in the recent July, and that's why we saw more cleaner days. And the thing with the data set that I liked there was not just the chart. We were able to just calculate, write an SQL query, share the query directly to anyone who is of interest. So I think that is one aspect of data set I really liked. This is one more I wanted to share. Time. Okay. And apart from this, there is also another source of AQI is this World Air Quality Index platform. So far this AQI bulletins and all is daily data that we scraped, and every month we try to update this data set. But if you want real-time data, there is this World Air Quality Index platform. It gives a free API. You can ping it almost, I think, 1,000 times per second or something. It's very liberal that way, a free API. So that has a lot of information about real-time AQI values. And I was toying around with that API and tried to develop something of this sort, where it takes, wherever I open this website, it takes the AQI value from the nearest monitor, and I tried to populate those moving circles with the pollution concentration, the particulate matter concentration in the air around me. And if I really open it, like this always works in Delhi. If I open it in Delhi, it's full, like all balls are moving around, and then I click on this mask up, and then like that is the only tool in my hand right now to help lesser particulate matter from going into my nose and lungs. So yeah, so these are few tools that, few things that we are able to do with AQI data, small data, but we will, yeah, I'll just stop there.
A quick question: how reliable have you found the government census to be?
Okay, I wanted to share that only. This short of time is what I thought, but so there's always this story of we were getting reading a lot of news about data manipulations that were happening, and again, same thing. We cannot claim things good or bad, but again, the tool is statistics. So we found one good tool called Benford law, which was implemented in China to test if China was manipulating the data. And that, again, this is only used to flag if there is any potential misreporting or fraud or data manipulation. The law basically says that the leading digits of any naturally occurring data set will follow this distribution. And we then tried to take each city and tried to plot, like just calculated a statistic to measure the deviation from Benford's law, and saw, okay, what is the status of monitors in those cities and also number of stations in those cities. What we generally found is that if there are more stations in a city, the deviation is less. But if there are less stations, we generally see a lot of that year, 2023 in Varanasi, is when we saw a news report saying that Varanasi saw a 70% reduction in air pollution. Obviously, like we thought, let's check, because satellite data was not showing so. Other cities around Varanasi were not showing so. So, like, how do we then comment about it? We found this one way to make some claim that, okay, if there is a deviation from Benford's law, maybe we can at least flag that there is some issue with the data.
Okay, I'm asking because
Thank you.
If you don't count, it's better. All right. Next up is Aman and Vivek, who are going to be talking about their experiments at diagram chasing.
how do I turn this on? Can I just connect the
You can just disconnect HDMI directly. Should just put the thingy.
Okay. One sec. Oh.
Access?
Yeah. Connects the cord.
Hello everyone, good evening. Thank you for sticking around till the second last talk of the day. And thank you to the Open Data Devroom for organizing this. I didn't expect IndiaFOSS to have an Open Data Devroom, but it's nice to see that they chose to have one. We're going to be talking about the work we do as part of diagram chasing, some of the lessons we have learned. Aman likes to call it full stack journalism, and you'll see what that means. If you want to follow the slides along on your own device, you can scan this, but I think the screen is good enough, hopefully. My name is Vivek. I like government websites, and I like publishing open data. And if I find a map of India with the wrong border published by the government of India, I am not surprised.
Okay, hi, I am Aman. I'm the other half of Diagram Chasing. I'm a designer, programmer. I'm a data journalism enthusiast. I'm not a trained professional. And yeah, I'm the other half of it. So for the past 1 year, we've been running this publication called Diagram Chasing, which is our kind of platform for experimentation, just collaboration, bringing in both of our strengths and seeing what comes out. So here are some of our works from our past year. I think Vivek is going to take you through the first one.
Yeah, so initially our plan was not to make this, but it ended up being something called BLR waterlog. What we did is map the natural drainage patterns in Bangalore. Bangalore gets floods very often, but it's actually just water flowing where it would naturally flow. So what the site has is a map where different shades of blue indicate how likely water is to accumulate in that area. Different popular places of flooding have POIs marked, and you can click them and find historical news reports from that area. Another thing we built as part of an open city data jam during the 2024 Lok Sabha elections is Who is My Neta? It's basically a platform where you could find out details of your, at that time, elected MP, find out details about their parliamentary activity, things they have reported as part of the election affidavit. So this went kind of viral because it was the elections, and lots of people don't know that this data actually exists. You can easily find out what your MP has said in parliament, assuming they've said something in parliament. And then after that, Aman worked on votes in a name.
Okay, so while we were cleaning up the data sets and joining these affidavits and other stuff, what I learned was that there are a lot of similar names for candidates who are standing in elections. And this was news to me, that there are namesake candidates who are put up by all sides to confuse voters. Maybe it's organic coincidence, but I don't think so. So for example, there are names like S.V. Ramani and S.V. Ramani who are standing in the same election, right? So this happens to Rahul Gandhi versus Raghul Gandhi. It gets reported because it's funny. Right, but I was curious about, are there other smaller elections where this has happened, and are there places where this could actually have flipped an election? So we did this large illustrated story on analyzing this data, on finding on how we found these similar candidates, how we passed through all of the elections that have happened since 1960s, I think, each election, each local election, national election. And then we did some analysis to narrow down candidates and occurrences which we were pretty sure were actually could have actually turned an election. So a popular example is Soumya Reddy in Jayanagar versus the Soumya A. Reddy, right? So a vote difference of 16 votes could have actually turned that election. This was a popular, this was also reported very widely, but we found many such examples which I did not find news reports of. So to my knowledge, this is the first analysis of its kind. Yeah.
After that, we worked on the National Time Use Survey. This is just a 0.0001% of the actual data they publish. The National Time Use Survey is done by MOSPI. They survey 5 lakh people across the country and ask them what they did in the past 24 hours. So you have a half an hour granularity detail of what 5 lakh people in India did, and it's across regions, demographics, economic groups, all that. So when you look at that, this Excel file, it's not actually one Excel file, it's 10 Excel files. And if you're not a programmer or data person, you can't use this. So it's technically accessible. I could download it. but I can't really use it unless I'm familiar with the process of using this kind of data. So I would say this is not accessible open data. It's maybe somewhat open. And there are multiple steps to get the data. First, you have to create an account on Mosby, which could be easier. The data is split across like 10 different files. Each column over there is some random code. You have to map it with an actual word. So 1 could mean male, 2 could mean female, 3 could mean transgender. All these codes you have to like manually reference a PDF, find a page in the PDF where it's referred. They use some random column headers. The documentation is in a bunch of PDFs. And fundamental problem is you need to know programming or data to actually use it. Most people who would use this data in real life, like a policy person, probably does not have the skills to use it that easily. So the data is not built for the people who would really want to use it. So it's technically available, but practically inaccessible to the people who would benefit from it. So what we ended up building is we cleaned up the data and we built an explorer. You can find it on the diagram chasing website. What you can do is explore all the data, run different kinds of aggregations and SQL queries directly in your browser. You don't need to open 10 Excel files and figure out what to do. So suppose you want to know who spends more time cleaning up after meals. The answer is pretty obvious, but to see the disparity is interesting. So on the website, you could group by state and gender, select activity code as cleaning up after, and then you get this on your browser. So this is the raw data. You can see every survey respondent, which gender, age, state, there's lots of fields. And we also have a summary view where you can get like aggregated statistics, the mean for males in Karnataka, the mean for females in Bihar. And directly from your browser, you can download all this data and do what you want with it.
So, like a lot of our work we don't want to create dashboards. I think that's a ground rule that we have, that each project should be taken on its own merits. We do not want to create dashboards. We do not want to create charts which you just show people, right? I think right now it's never been easier to prompt a dashboard. Okay, you go to some website, give me a dashboard, here's my data. You get something which looks like this, purple gradient text, lot of boxes, big text, and you do what you want with this. But I think the problem is that you desensitize your audience to data, because I have seen like 5 pothole apps over the last 1 month, all right, on Twitter, on Reddit. I think there's a risk in desensitizing your audience where the audience just stops caring about the data, the dashboards, right? So then how do you, our goal, personal goal is, how can we make this more inviting? How can we make this more accessible? And these are just our subjective thoughts. A lot of it has to do with web applications, because we do that kind of work. So these are subjective thoughts, obviously. But I think one of the biggest project that we've undertaken is something called CBFC Watch, which I'll take you through. And a lot of the thoughts come from this project. So CBFC Watch is the first searchable archive of film modification in India. So all modifications run by the Censor Board of India is searchable for the very first time. We have an archive of 18,000 movies, 1 lakh modification records that you can search for the very first time. So you can actually go to our website, and we have a nice search function where you can search for keywords like maps in a language, in the English language movies, in a certain year, in a certain genre, for a certain actor, director, whoever you want to search for. We have also cross-linked and cross-referenced 18,000 of these movies by this metadata. So if you're interested in Akshay Kumar, you can look at Akshay Kumar, you can look at what themes he's usually censored for or not censored for. You can draw all these comparisons. For each film, you can understand in its context. So on each film page, we have these charts that show you what the relative distribution of modification is, where does this particular movie fall, what actions were taken, what themes were unusually modified, what were usually modified, and so on. So this is what we've been working on, and Vivek is going to start off with how we got to building this.
So I'm not sure how many of you even knew that the Censor Board publishes this. Normally, how you have to find this is you'll search for a certificate that looks like this somewhere in your theater. And in person, it looks like this. It's probably next to the toilet. And when you scan, so on the bottom left, the bottom right, there's a QR code. When you scan that, you get a page, this page. Each record is a modification made by the Censor Board in the film. So this particular one has 7 modifications in the film, and there's supposed to be a duration attached to each one. In this case, everything is 0 seconds. They didn't enter the data properly. But since we have a URL, which is what we want, and it has an interesting pattern, it has 2 URL parameters. The I parameter is what we're interested in. But we have a URL with numbers. So now we can try to make sense of how they host this data and how we can extract it. So we try to decode the URL parameter. We try a bunch of different numbers which turn out to be successful 200 requests, but there are a bunch of 404s as well. But these 4 turn out to work. So we try to figure out, like, is there a pattern to this? So the first 4 just some kind of prefix. The next 2 appears to be some kind of code. The 4 digits following that is basically the year the film was certified plus 900. And the last 7 or 8 digits is a sequential certificate number. So now we crack the code maybe, and we can just iterate over every possible certificate which is hosted on the website. So we try out a bunch of values. We get a bunch of 404s because for some reason the sequential numbers are not really sequential. There's like one gap in between. We haven't figured it out, and I don't think they care at this point. You'll find out soon why. So now that we have the URLs, you have to figure out how to extract data from each page. So my favorite thing is to just open the network tab and see what the browser is doing. So, and as an example, we open one of the certificates, and on the bottom, that last request, the QR redirect one, if you check the JSON, not a JSON response, just some random response from that, it has the data we're interested in. So what we do is we download the QR redirect post request response for every film, and you can't do that directly actually because there's a bunch of requests made before that. It has cookies, there's different, it's an ASPX website. I'm not sure how many people have used an ASPX website, but there's lots of state involved in every request. So what we had to do is we had to export all the network requests as a HAR file. HAR is basically the standard format for like saving network requests. I'm not an expert in this, but it works for me. So what it contains is all the HTTP requests, all the cookies, session IDs, everything. So this is a small sample of what we got for our website. The actual HAR file is like 600 KB. So if we had to dig through 600 KB to find out what requests are being made, it would have been very difficult. So what we do is what everyone does these days. We fed it to an LLM, and it turns out it's very good at what we needed it to do. So we fed this HAR file to an LLM, asked it to generate a scraper, and it did a pretty good job. This is approximately what it looked like, the script we generated. Each step, one ribbon request, some other follow-up requests. And there's like 7 requests you need to make before you can make the QR redirect request. But turns out this LLM solved most of our work. And soon enough, we had a functional scraper, so we downloaded all the files we needed. And one tip I would suggest to everyone is, when you download something from a government website, never delete what you download, because it may not be there tomorrow. So now that we had the HTMLs, we have to clean it up a bit, and we just exported it as a JSON with the fields of interest. So we have like the category of the film, language of the film, people involved in the film. And we do this for all the films. We dump it into a CSV file with the fields of interest to us. So we have a CSV file now. I think people will be pretty happy at this point. But it turns out the CSV is still a big mess, because when you open it, you see there are film modifications like this. You can try to read and understand. I don't think it's that easy to understand because it's a bunch of numbers. So what we really cared about is what is being modified, where it's being modified, and how much is being modified. And also not just modifications. We also wanted to add context, like who made the movie, who acted in the movie, which studio made the movie, when did the movie release. And the end goal was to sort of analyze trends in the way the censor board censors stuff in films. So we made an attempt at first. Aman spent a lot of time on this.
Okay, so just a fair warning, there's some explicitives on the screen, but if I censor them, then I mean, it's just pointless, right? So the first thing that we tried was hard coding just what to look for. I want to look for profanity. I made a huge list of profane words. Violence, religious topics, political topics. But these people sometimes don't care about spelling, right? They don't care. They generally don't care. If you trust them enough to spell things properly, maybe this would have worked, but it does not. There are also regional languages. There are regional words which I can't account for, right? So while I was doing this, also just since we are on the LLM topic, we never use LLMs for analysis, right? I would never ask an LLM to say what's interesting from this, please generate it for me. If I don't care about it, I can't expect someone else looking at the data to care about it. But then why here, right? So Vivek said something to me that if you are categorizing these manually anyway, if you're making these lists manually, it's a subjective decision that we can pass on to the LLM because it will just be maybe just as good. right? So then the attempt number 2 was operationalizing a pipeline which did this. LLMs are great for classification tasks. So how this works is you write a detailed prompt with all edge cases, all the categories that you wanted to generate, like action types, was it a deletion, insertion, replacement, modification, what category of topic, violence, profanity, religious, political, whatever you want. And you can define a nice JSON schema. And you can ask the LLM to always respond in this structure, right? So it makes it very easy for you to then put into a CSV. So then we could like give it random sentences and it would always like classify it correctly. And this was great because the scale of the data was like a 1 lakh records, and overall like experimenting with this cost us only around like 12 to 1500 rupees, which is great. Which is great value for the kind of metadata that it created for us, because what this does is now you have sentences which initially look like this, and now you can actually get some structure out of them. You can get a clean summary of what happened. You can actually generate categories which you can use for counts analysis, time series analysis, whatever. You can also generate like topics. You can extract the main topics out of the sentence and generate a list of them as well, right? So suddenly then this becomes like analyzable. You can actually track changes across films over time instead of just having natural language text. So yeah.
So we have a CSV now, but I don't think people just look at CSVs. They need some help using it. So what we found interesting is to find ways that people will find interesting data themselves. Otherwise, like, it's just data. There's nothing interesting for them. So we wanted to communicate this excitement, and what does the user want from their point of view? That's what we wanted to figure out in the data. So they would probably want to find movies which they're interested in, search for keywords, share the movie with others, and just browse to the data set in a more convenient way than a CSV. So a few things we like to put on our websites. One is having permalinks. Permalinks make your site much more shareable. Now you can just send a film you like to anyone. They don't have to open your site and click 10 different buttons to find the film they want. You can share an actor, particular content, things like that. We use something called TypeSense, which is a FOSS alternative to Algolia. We wanted to have a bit of slightly complicated search features on our website, and TypeSense turned out to work pretty well. So by default, TypeSense, this is a demo they have on their website. This has a bunch of random toggles and buttons. We don't think this is good because I can't scroll to 50 different toggles to figure out what I want. What people want is something they're familiar with, which is something like Google search. All search engines use this. It's not just Google. Even DuckDuckGo can do this, by the way. What you can do is search for Ijipura flyover from a particular website since 2019, because everyone talks about it and you would like to search more about it. So TypeSense by itself does not have a very straightforward parser. We had to build a slightly custom parser ourselves. So we extract this field pattern and we can get things like exact matches, wildcard searches, and comparisons. So we build this, and now we have much more powerful search on the website. So when I have a website, when I'm looking at a website, I would want to search for things like this. So of course, when I'm building something for someone else, I should build it like how I would want to see it. And one key point I feel about things we build is that what we build is just one way of viewing a data set. It's not the only way to view a data set. When government releases data, it's in specifically one PDF format because they don't want people to use it any other way. But I believe that data should be accessible to be used in multiple ways. So how do you think about the users who are going to look at the data and how they would like to use it? So one thing is to give them examples of how they can use it, how they could slice it. So over here, if they're interested in the kind of content being censored or which regions of the censor board are censoring things differently, these are examples of how you could use it. We also try to document all the data we put out. So we put out a data dictionary with the description of every single field. And we hope that people don't have to guess what the data is about. It should be pretty clear with the data documentation how you could use it and what each field means. With CBFC Watch, we also put out a detailed notebook written in R, because Aman likes R. And you can recreate lots of the analysis we did on this notebook. And turns out, because we put a notebook and lots of documentation, other people actually used it. So this week, The Hindu published 2 articles using the data on CBFC Watch. This is one of them. And Vignesh is the person who published the article. This is what he said. What's there to consider? You brought it on a platter. When you make data that easy for people to use, they are going to use it. And documentation obviously helps with that. And because there's a notebook, you can also recreate what they have done and fork it in a certain way, because you can just change certain things in the notebook and get a chart that might be of more interest to you. So one part of this is that design and UX are not just a visual part, it's also the way the system is designed, at least with data, government data in India. But it's not just government data, even we as engineers and programmers, like I'm guessing lots of us are engineers and programmers, we feel it's not worth spending time on glitter, on like features that make it nice to use. But when you use a site or a platform with good design, it's quite evident that there was actually thought put into it. So one example of bad government UX and design is the Survey of India. Has anyone looked at a Survey of India map? Okay, that's more than I expected because we're in an open data dev room. But if you haven't, the reason is probably because it's almost impossible to access. First, when you open the site, you get this. You have to fill in what is called an seat OSM number. Now I want a map of Nimans, I have to figure out this number. Once I get the number, I get this form. I have to give my mobile number, get an OTP, create an account, get a password, type a CAPTCHA. And then I get a file in a format I don't understand, so I have to figure out how to use the file. But you could use OpenStreetMap and you can get the data in 5 seconds. So why would I use this government website? So this is not just with maps, there's like all kinds of data which the government puts out which they make impossible to access. As an example, I recently scraped the Parivahan portal, which has vehicle statistics of RTO registrations, all kinds of data about vehicles. So suppose you are interested in electric vehicles. BYD is a Chinese manufacturer of electric vehicles, which Trump really hates, and I think it's banned in the US currently, if I'm not wrong. But in India, we are importing lots of electric vehicles. So if you were in the policy field related to electric vehicles, you'll be curious. How many BYD cars are being registered in different parts of India right now? So if you wanted the data from the government, luckily they at least have a portal, Parivahan. You open that, you're greeted with this. There are like 20 different panels and numbers. Where do I find numbers for Bangalore? So what you have to do is you have to select your state, your office, then select the category of the year, and then you have to select the manufacturer and then scroll down and you find the number you want. Now this is just a number for one RTO for 1 year, for one manufacturer. Now if I want this for, there are like 1,400 RTOs in India. How would I run any analysis on BYD cars in India with this? It's impossible. So it's a multi-step process. It's not meant to be used the way you may want. It's for a very specific use case. They don't have any documentation. I happen to know where to click to get this data. If you didn't, you'll probably get stuck on the way. And even if they have data, it's probably not that good, but at least it's something. But how could this be better? So what I did is I scraped the data, created a custom UI. So you can find it there, indiavehiclestats.pages.dev. But the main point is that I can permalink to the thing I want. So I'm interested in BYD India Private Limited cars from Karnataka in 2025. So you could just share this link with someone and they could get a number that's right there. They don't have to navigate a massive UI. And when I release data, like I mentioned, I try to put a data dictionary. So if you want to run some analysis, it's much easier. Now you can just run SQL queries on the data. So when you design, it should be for the lowest common denominator. I think lots of open data tends to be built for data people, but most people who want to use data are not necessarily data people. So you should be designing for low friction, especially for people who may not be comfortable with data. And most people use the browser, so ideally you would build platforms which they can open and data they can open in a browser. Flat GitHub, HiParquet, and Dataset are pretty nice tools for making data accessible on a browser. They don't have to download a CSV, open it in Excel, do all that.
Yeah, so when we are building web apps, Vivek is a DevOps engineer and he tells me that I don't want one more thing to maintain in life, right? So I want to build a project and I want to move on from a project. So that becomes important consideration. For most of our projects, I would say CVC Watch is the only thing which has some moving parts, but almost everything can be static. If you're building something which has interaction, which is a dashboard, make it static, move on with your life, right? It will live forever, it has no costs. Almost everything can run in the browser these days for free. I have built teaching tools with R which runs in the browser, so you don't even need to download R, right? it's a great space. It's a great time to be like building stuff, build static stuff. That is the best thing to do for you as a builder. So yeah, now this is like the philosophy part. Like this is the subjective philosophy part where I think there are some general principles that maybe we can use to just when you're building stuff with our open data. Start with the user's intent. Don't not think about like, okay, this is the data, I'm just going to put out the data, CSV done, right? How can this appeal to someone? What are the different people that I'm considering this for? What multiple entry points can I offer them? With CSV Watch, we have a search for people who just want to search. We have a detailed notebook of analysis for journalists who just want to analyze the data. We have a CSV if you want to use that, right? It's just one view of the data. Your creation is just one view of the data. There can be many more. If you can't link to it, it will not exist. If I cannot share something on my site, if I cannot directly link to it, people are never going to get to it, all right? So this is something that we focus on. How can we permalink everything? Even the analysis done in the Time Use Explorer, if you set certain filters, you can copy a link and you can send it to someone. The exact same query will be loaded and it's all static in the browser, no server required. Documentation is a first-class feature, is not an afterthought. There are detailed data dictionaries. Now we'll be putting out notebooks and so on. So the idea is to invite people in, create sample charts, do sample analysis. If you are interested in data, why do you care about the data, right? Show me that. Maybe I'll get interested in it too. So yeah, documentation is a first-class feature. It's not an afterthought.
I'll just go to this quickly, but normally when I scrape data, I try to keep it with a tree script workflow. One is a fetch script to actually scrape the data from the government website. I use the network tab and HA files as I mentioned. I have a parse script to get normally HTML into a better format, and then I aggregate them all into a CSV or a more single file format which people can use easily. An example of how having multiple data sets is useful, you can combine them. So for Who's My Data, the data we have is actually from 3 different sources, but when you actually look at the UI, that's all abstracted away. You don't have to worry about where do I get this data from. When you're able to link and combine different data sets, you get better value like this. Sometimes there may not even be a data set. What we did with BLR Waterlog is we manually just went through all news articles of flood incidents and we aggregated them like this.
Yeah, and like one of the last things is beauty and craft matter. If you don't want your data creation to be lost and someone have to recreate it all over again, make it memorable, right? We treat aesthetics with just as much like importance. We want people to share this. We want people to come back to it. I would say design is not an afterthought. It is the central thing which makes these projects take longer, but I think it's worth it. So yeah, I think all of it should be open source. All of it should be reproducible as far as possible. Do not hide anything. People should be able to use it. And yeah, that's diagram chasing. That's us. This is. Do you want to say what this is?
I filed an RTI last month with the Bangalore Metro Corporation. They sent me a 10 MB Excel file, and I'm going to publish something this week with that data, hopefully. This is a preview of that data.
Master of Ceremony says 2 questions. Anybody? No, it needs to go into the thing.
The name behind diagram chasing, I'm curious about the naming, yeah.
Wow, this is out of syllabus. It sounded cool. Like the thing is, like when we are chasing, like when we are working with a data set, I know that in my head there's this graph that I want, and it might take like a few months to get to that. With CVSC Watch, I wanted that trends of content, and it feels like that's what I'm doing. That's what we are doing, just like sitting with this one CSV for like 8 months. So yeah, diagram chasing. I don't know, like so. I don't know if we have time. Like, we don't have time.
Yeah, but we have one question here.
Okay.
How do you develop an eye for interesting analyses?
Okay. I think it's like it's an acquired taste kind of situation, where I think it's also frustration. Like, because I think I hear a lot of people complain about there's no data, right? I think there is data. I think like we as sometimes like people who are knowledgeable about it fail to communicate it, right? So sometimes he brings up a thing and we have an argument, and I want to prove him wrong, or he wants to prove me wrong, right? So the graph then is generated out of spite. So it's about like, can I have an argument over this thing? Can I have a conversation about it? If it's as interesting as that, maybe it's interesting to someone else as well. So maybe that's the short answer. Yeah, thank you.
We have the last talk of the day. Next up, Keshav is going to give a talk on federated code and building data sets that sync.
This will work?
Your present overview will not work unless you have internet.
Oh, yeah.
Hello? Okay. Have you connected to the internet somewhere?
I will have to check.
Should be the fastest. Start a slide, turn off film strip view.
Yep.
And then start your slides, and whenever internet shows up.
Yeah, it's
there. Perfect.
Yeah.
I'm going to run a timer for 15 minutes. You can see your slides there, so you don't need to turn back.
Yeah.
And 15 minutes, you can have questions.
Okay. Yeah. So hi everyone. So this talk will be a bit different. Like we'll be focusing on open data. Yep. It's not working. Oh. But I have added presentation in the drive also. Like. Yeah. So in this, like, we'll be talking about like open data, which is mostly meant for consumption by like developers, OSPO teams, folks in the security, right? So in this session, I will take you through how we use like ActivityPub in a non-trivial way. So ActivityPub is basically meant for like social networking, but here we will show like how we use ActivityPub to share like this open data between various tools and systems and the stakeholders in a decentralized fashion. So a bit about me. So I am full-time maintainer at ActivityPub, where I maintain tools related to SCA and supply chain security. I also mentor various GSOC projects there. So this is the brief agenda that we will try to cover. So the open data that I am talking about here is like package metadata. We will see what this package metadata is actually. Then we will see how we generate and consume this package metadata in our about code SCA tooling context. Then we will see why is the need to share this metadata. Why should we care about sharing this? Then we will have a quick overview of what this ActivityPub is actually about. We will see then federated code architecture, and towards the end, the benefit and learning sort of it. So yes, so the package metadata is basically like the structure information, the basic truths about the package, like the license, like the dependency, entire dependency tree, any known vulnerabilities, all these sorts of stuff, download URLs, repo URL, these sorts of stuff. And why should you care about this metadata? Because you need this metadata to do license compliance, right? You need this to do like vulnerability management, to generate SBOMs, right? To enforce policy throughout your orgs, right? So this is like the very subset of like about code SCA tooling, where we have like PearlDB, vulnerable code, and scan code IO. So PearlDB is where we ingest all the packages out there in various different ecosystem, like it can be NPM, NuGet, PyPI. We scan all of these and create an index out of it, which we will use later on. We also have vulnerable code, which is like open source and open vulnerability database, where we collect vulnerability data for open source package from various sources. And then we have scan code IO, where we integrate all of these package metadata to do scanning and matching, right? So I can't, very short time to do demo, so I have added a screenshot. This is the screenshot for like PearlDB, where we have like close to 21 million packages and their metadata. This is what a typical scan looks like. It is a long JSON file where you have license detection, dependencies, right, and file level informations in a structure format. So this is vulnerable code where you can search for package vulnerability. You can using package URL. You will get all the vulnerability related to package, exploit, various severity scores there. And this is the scan code IO where you can integrate all of these. On the right side, you are seeing the foundational pipeline that you can run to scan package, to use to match an unknown code using those metadata that you get from PearlDB. Then you can have like vulnerability detection using vulnerable code, and you can do like SBOM enhancement. So you have existing SBOM, you can import those and enhance it using the index of package metadata that we have already. Yeah, the big question is like, yeah, these metadata are important, but what is the need for like sharing these? Like, so basically this is the lay of the land here. Like we have like various deployment of award code in ourselves, and in like community there are a lot of folks that are using award code for like security and compliances, and they run their scans for this package metadata on their side. So, and there are other tools out there like ORT, Turn, Fossology. They are also using our scan code toolkit under the hood. So, but the thing is like this package metadata are the fundamental truths about the package, and they don't change if you scan package multiple times or at various different locations. But the thing is like this package metadata scans are like compute intensive. If you like scan all the packages that are available in like NuGet or PyPI, it can take a lot of time to build those index. So what is the need is like we should be able to share this metadata in the community, and this metadata should be directly, very easily accessible to all the open source developer out there, so that together we can have a resilient software supply chain. So this is like the obvious way to do this, like in a decentralized fashion, and the obvious thing was like ActivityPub. So ActivityPub is basically a decentralized social networking protocol where for information exchange we use like a activity stream standard. If you want to understand like ActivityPub in a basic sense, like it is the users on this network basically has inbox and outbox. And any communication that you want to do through to the world, like say you want to send DM, you want to post something, you want to follow something, you compose a specific activity stream and put it in your outbox, and your host ActivityPub will go through your activity stream and do the needful. Here we can take a small example of this. So if you are here at the FOSS India and you want to make a post that, yeah, hello IndiaFOSS, you will have to put that in the content, and you will have to add the receiver as a followers. If you want to make public, you can add public group and send it to your outbox, and from there on your host ActivityPub server will take care of it and federate it to your followers. If they are on the same server, you will get it in your inbox. If you are not in the same server, it will be delivered to your like server and from there to your inbox. Yeah, we end up using this ActivityPub, but the thing is like in our system, like there are no users, like human users. So it is basically just packages. So package becomes the first class citizen, and the activity that they do is like they don't post something, they don't follow someone, they don't send DMs. The activity related to package are like creation of a new package, discovery of new scan or new vulnerability, those sort of stuff. So if tool or system follow this package, they will regularly get the notification about these events, and they can keep themselves updated. But the thing is like I showed you in like beginning slide what is this metadata looks like. It is a long JSON file. Sometimes it can be in gigabytes, and we have close to like tens of millions of packages. So in our demo instance of PearlDB, we had like close to 21 million packages. So it is very impractical to move this scan across the network. So what we do is like when you will receive this activity notification, you will get the nature of change that happen on the package and the reference to the metadata in the Git repo, right? So this is what it looks like. So we have like data layer and an event layer. So in data layer, we do like mining of these packages and metadata in the CI, and we store in the Git distributed Git repo based on the ecosystem. And a summary of these like changes goes to the event layer, where a worker will take it and create an activity stream for all the packages, and that will go to the package outbox. And from there on, ActivityPub will take over and make sure to federate it to you if you are following it, no matter in which server you are. So this is basically meant to be used through an API. So, but we have added a minimal UI so that like humans can see and discover packages and events on the that are happening related to package. So the benefit and learning side of it is like, yeah. So earlier when we used to like deploy this like matching index like PerlDB, it used to take a lot of time to populate this index. And if someone else is deploying this stack, they will have to go through this compute process. So there were a lot of duplicate compute and time delay in this. So now we can like reuse this, and we are up for like using the matching index very quickly. We just have to do git clone and subscribe to the package activity. So this is how the lay of land have changed. So we have like multiple federated code deployments which are decentralized, controlled by different entity, but they are interoperable. And all of these different scan, instead of doing all this duplicate compute, they can just fetch those package metadata directly from federated code servers. And if they find out that that package metadata is not there, they can do the scan locally and put that into federated code server that later community can use it. So so this is like something in the future that we are trying to work on. So right now what you have seen is like data moving from package to the user and the consumers. So but there is a flow of information in other direction too. So if you right now focus on that particular CB, like for the package Webpack dev server. So if you go and search this CB on GitHub Security Advisory and like NVD, you will get two different set of like affected package and patch, right? And if you are like the developer, you will be confused about like what should you do here now. And I can assure you this is not some random or fluke instance. So we have a dedicated pipeline in our vulnerable code where we detect this kind of anomaly. So they are close to thousands of such anomalies where we have for a particular vulnerability, various different sources don't agree on what is the affected package or what is the fixed package. But this is like a serious concern. So here we have a community curation feedbacks where the folks that works in the security or upstream package maintainers, they can chime in and like put in their feedbacks or curation that which one should the users or consumer of this package should prioritize. So so this hopefully we will have something to talk about this by the next FOSS India conference. So with this I will leave you guys. So I think I have 3 minutes for the question. So these are like our like Slack channel repository which you can go out and see, and you can get this link to the slide and like see our projects here. Any questions?
I had a question on why did you pick Git as opposed to like anything else?
Yeah, so like basically to say like it's cheap, it's free, like the basic thing, like what's the open source community is like very cost sensitive, right? So we want to make sure like others can deploy this like federated code, and if there is like dedicated servers, it would be like more of a cost for them.
Can you give us a sense of I will not exercise power, like manpower.
You mentioned ActivityPub, other people will be contributing to all the packages.
Yeah.
So how do you establish authority? So let's say he wants some wrong package information to be inside the whatever is the chain.
Yeah, yeah.
Would
So
you be able to?
yeah, so the thing is like basically in this flavor of ActivityPub, like package is first class citizen. So if I have a federated code deployment, this federated code server can create the package like user with like package URL, right? Not other folks can, right? So if you like come and you set up your own server and then you do, and you push say like say fabricated curations, yeah, folks can choose to block your server. That's what like happened with Mastodon, right? Mastodon can choose to like blacklist certain servers. So same thing we can do here. Yeah. Yeah, thank you everyone.
That brings us to a close of the Open Data Dev Room at IndiaFOSS 2025. Thank you everyone in the audience as well as the live stream for sticking with us, and hope you enjoyed our talks. If you liked our speakers, please give them a follow. Please reach out to them, ask them any questions that you might have. And if I would like to thank IndiaFOSS team for helping us make this a success. Dev rooms are an experimental thing that we are doing at IndiaFOSS for the first time, and it's nice to see such enthusiastic response from both the IndiaFOSS team as well as all the people and the attendees and the live stream audience that we have. So thanks everyone. I would also like to thank our sponsors. If we can switch to the sponsor slide on the live stream as well. A big shout out to them for making this even possible. And this dev room was made possible via volunteers. There's Gaurav, Tej, Karthik, Unnati, and Adi for being a Red Hawk volunteer and helping us today. That's all from us right now, and hope to see you next year at IndiaFOSS. Bye everyone.